都有 upload 嘅，頁面肥啦。咁喺頁面肥嗰度咧，其實佢寫住可以用喺泥嗰度都可以噴頁面嘅。咁樣我哋嘅使用方法咧，咁樣淨係噴頁面，淨係噴頁面，唔會落到泥嗰度啊。咁樣留意翻呢個頁面肥咧，喺 Lab 3嘅時候，我哋都會，你會見到都有頁面肥嘅一個使用啦。咁我哋都係用翻同一款嘅頁面肥，咁樣都係呢一個嘅。咁樣然之後咧，去到呢啲 discussion 呢啲 reflective question 嘅位啦，可能就大家會比較多嘅疑問啦。咁樣就係你哋要比較個 target 係兩種唔同嘅 soil matrix 係比較多嘅，係。咁咧，因為佢哋兩種 soil matrix 本身嘅 nutrients contents 就係唔同啦。咁樣然之後你比較佢哋所種植嘅嗰啲番茄苗嘅一個生長嘅狀態嘅唔同。咁樣然之後，雖然我哋係有用頁面肥嗱，但係兩者其實都有用頁面肥，但係你會發現，就算兩邊都有用頁面肥嘅情況之下，對你個生長嘅狀況會唔會得到一個好大嘅改善咧？咁樣會唔會喺原本個 soil 嗰度冇乜 nutrient 嘅狀態之下，你淨係加頁面肥都可以令佢生得好好咧？咁樣你要睇下你比較個重點喺邊度，係啊。咁樣就呢度係 Lab 1 report 啦 ，Lab 1 report。咁我哋比較嘅重點其實係要 discuss 翻嗰個 soil matrix 入邊可以 provide 到俾個 tomato plants 佢生長嘅一個 nutrient 嘅所需是否足夠啦？咁呢度個title 寫住 nitrogen 啦，咁其實唔單止要 discuss 個 nitrogen 啦，咁樣包含埋其他嘅 nutrient content，咁樣就大概係咁多。咁 Lab 1你哋有冇咩問題啊？仲我睇下而家有幾多人？好，如果 Lab 1冇乜問題嘅話咧，咁我哋今日我哋上堂就講到呢個 chapter 啦，講晒 sampling analysis， 仲有個 fertilization 嗰個 part 嘅。咁樣然之後今日咧，我哋有3個 chapter 要講，咁樣就等陣我講咗，我而家講定等陣講啦。唔係，我講咗個 lecture 先，咁樣然之後可能講完 lecture 5呢一 part 之後啦，咁樣我就會再講埋呢度我新 release 咗出嚟嘅一個 Lab 3嘅，咁我等陣我會再講下 Lab 3嘅一個 lab 嘅一個設置啦，仲有 lab data 啦，咁樣你哋嗰個 Lab 3 report 係要點樣去寫啦？咁樣呢個等陣會講啦。咁樣另外仲有一個 field trip 個 future report 嘅，咁樣個 future report 咧，咁樣同樣地都係個 future report 都係同樣地，我會俾 data 大家，咁樣然之後就會大家跟住我啲 field trip data 啦 field trip class data 去寫翻呢個 future report 嘅。咁我等陣都會詳細講。咁我就上咗 lecture 先，我講晒 chapter 5之後咧，我哋再嚟去講呢兩個功課要點樣做，因為個 field trip 嘅一個功課個 future report 咧，咁樣其實都要用到 個 future report 都要用到我等陣講嘅一個內容啊。你哋要用到個計算方法嘅，咁我會講咗個 lecture file 先。好，咁我哋而家就上堂先。Okay, let's talk about the plants and fertilizers because in the lecture 2 we already mentioned that they have 17 different essential nutrients for the plants, and also illustrates the deficiency symptoms, the toxicity symptoms, as well as the nutrient functions, the different elements functions in the plants. So if we want to improve the soil fertility, improve the nutrients level in the soil or in the plants, we need to use the fertilizer. So how to select different type of fertilizer is a very important point for these parts because in the organic farms have a different fertilizer selections, and in the conventional farms, and they have more different types of selections for the fertilizers. So why use fertilizer? Because we want to improve the soil fertility and also want to increase the crop productivity to ensure the plants have satisfied productions on the farms, and also to extend the arable land used, and to increase the yields on the land carbons in production. Also, the suitable fertilization can help to ease the disease and pressed on your plants, and the potential for putting new land into production is limited. And if new lands are available, they are often less productive. So the fertility, the nutrients level is a very important factor for the production. So meet the future food needs with increased crop production through greater yields on existing farmlands is a more favorable scenario. So here you can see that here shows some example. For example, here shows some example, such as the cereal production accounts for about 15% of world fertilizer use. So to ensure the productivity of your economic crops, you need to ensure you have a good management for the nutrients on your farms, and then to support for the plant growth. About 17% of the global fertilizer consumption is in developing countries, and have been growing since the Green Revolutions. Improves the temperature and the tropical climate. Fertilizers serve the identical purpose of supplying the suitable, the adequate the amount of nutrients to crop plants to produce high production, because the suitable temperature and tropical climate will make the microorganisms and the whole reactions, their activities, and more fast than the colder area, and then accelerate the nutrients transportations in the soil and plant system. And increasing the agricultural production does not automatically meet a proportionate increase in the fertilizer use is needed. And so that's why we need to calculate for the nutrient use efficiency. We already mentioned this term in the last lecture. And why the nutrient use efficiency is highly recommended and is very important terms for the nutrient calculation, because for the organic farms, for example, in the organic farm, not too much not too much fertilizer is recommended to use on farm. The target to reach sustainable nutrient cycle. So, for example, after the harvest, the residue of the plant is recommended to put it back, and after the decomposition, they can release. They can release as different available nutrients into the soil and return back, and all the nutrients in the residue firstly come from the soil, and then when they are being harvested, they will put it back into the soil, and the nutrient can return back into the soil. So that we don't need to add the fertilizer every year. So from the build up to the maintenance for the nutrients, so different amount of fertilizer is being needed for the nutrients management. And the type of nitrogen fertilizers, and for the nitrogen fertilizers in the chapter 2, the lecture 2, we already mentioned that there are different forms of nitrogen in the soil, and both of them are necessary for the plants that have the nitrate, nitrite, as well as the ammonium nitrogen, and they have their benefits. Both of them have their advantage and a disadvantage, and we already highlight their absorption and transportation, as well as the assimilation in the plants. So we can know that nitrate is more easily and have a higher accumulation in the plant. And however, for the assimilation, the nitrate and nitrite need to convert as the ammonia first, and then they will be used as other amino acids, or further being used as the protein in the plants. So here we have list different nitrogen fertilizer, and the first one is the ammonium fertilizer. Ammonium fertilizer usually have 18% the nitrogen, ammonia, and also have ammonium sulfate have a 21% nitrogen, or the ammonium bicarbonate, and this one have the 17% nitrogen, and all the moderately to quick acting. So for the agricultural purpose or horticultural purpose, and the nitrogen fertilizer application, you need to think about the reaction and the releasing for the nitrogen fertilizer. And for the horticultural purpose, they are suggest to use the long-lasting fertilizer and the slow releasing and the slow acting fertilizer, because they can support for a longer time, usually more than 3 months. That just apply one time can sustain for 3 months. And however, for the agricultural purpose, they need to harvest for the economic plants. So for the agricultural purpose, they need the quick-acting fertilizer that to ensure the plants can absorb these elements as soon as possible, and the uptake by plants can be retarded by additions of nutrification inhibitor. So the nutrification inhibitor, later I have a more detailed illustration for this reaction. So the nutrification inhibitor will affect the ammonium fertilizers reactions and the release and are being absorbed by the plants. And the other fertilizer, nitrate fertilizer, have the calcium nitrate, sodium nitrate, and trillium nitrate. Trillium nitrate is also shown as the sodium nitrate form, and all quick acting and also increasing the soil pH. In these situations, you also need to consider how to adjust the soil pH, how to balance the soil pH if you used the nitrate fertilizer. Ammonium nitrate fertilizers and have the most commonly forms such as ammonium nitrate that have the 34% nitrogen, or the calcium ammonium nitrate can contains the calcium carbonate, and the nitrate can support the calcium and nitrogens in at the same time, and as well as the ammonium sulfate nitrate. It contains the nitrogen and the sulfate, two different elements. And another one is the amide fertilizer. The urea is most commonly nitrogen fertilizer being used in the environment, and the calcium cyanamide. And this one have the 20% nitrogen. And the solution, we always see that the nitrogen fertilizer always is seen as can always easily to be dissolved into the water and make it as a nutrient solution. And solutions that contain more than one forms of nitrogen, and such as the urea ammonium nitrate solutions that have a 28 to 32% nitrogen, and the slow release and controlled release fertilizer. We mentioned a little bit in the last lecture. The controlled or slow release fertilizer always have a coating that need to when the coating is cracked or dissolved by the water, that the nutrients inside can be released into the soil, and either the derivative of urea with the nitrogen in large moleculars, or the granular water-soluble nitrogen fertilizers. Controlled release urea encapsulated in thin polymer fields, and slow or very slow acting according to the type of polymer or thickness of field. And the polymer is cannot dissolve in the water, so it depends on the hold of the polymers that controls for the releasing rate of the fertilizer, and all often includes a quick acting component, because when the chemicals inside of the coating, when they are being released, they are quick acting, has a fast release into have a fast reaction with the in the soil, that to ensure the roots of the plant, the microorganism in the soil, can use these elements as soon as possible. Or other means of slow release, such as the sulfur coated urea, and also have the multi-nutrient fertilizer also containing the nitrogen, such as the nitrogen phosphorus fertilizer, have different forms of nitrogen and phosphorus, and the nitrophosphorus or ammonium phosphorus or diammonium phosphorus. And in these multi-nutrient fertilizer, they will exist in different forms with different valence, and also will affect the contents of the nitrogens in the fertilizers, or also affects their releasing rate. And also have the nitrogen and the potassium fertilizer, for example, the potassium nitrate, or the fertilizers containing the nitrogen, phosphorus, and the potassium at the same time. And here I talk about the urease inhibitor. What is the urease inhibitor? They reduce the rate of the first hydrolysis step, and to slow the rate of ammonia production. It can help to reduce the ammonia loss to the atmosphere. Because if the ammonia, with the ammonia uh, through the reaction being released to the atmosphere, then we will reduce the nitrogen content in the soil level, and also will cause the further contamination in the air, in the atmosphere. So only a few that they are not non-toxic, effective at low concentration, chemically stable, and able to be mixed with or coated onto a urea containing fertilizer. So the urease inhibitor always mixed in the urease containing fertilizer. Try to reduce the ammonia lost. And here you can see the reaction. How does the urease being used and being released in the soil environment? And firstly, they are being dissolved into the water, or being applied in the soil when they have a reaction with the water molecules, and with the help of the urease enzyme. So the urease is produced by many soil microorganisms and the plants, and also present in nearly all the soil. So they will have the reactions to form the ammonium bicarbonate. Um, and in this situation, they will be used by the roots of the plants, or the other microorganisms. And so the help of the with the help of the urease inhibitor, they brought this process try to reduce the formation, the reaction, or the release for the ammonia. and try to keep more available nitrogen contents, nitrogen fertilizers in the soil. And also you can see that when they have this reaction, when they are being formed this serve and released for the ammonium and the carbon dioxide, the temperature, the pH also will be increased, and the ammonia gas is produced, and the loss of ammonia tend to the volatilization can be formed from 0 to over 15%. So is a very high release for the nitrogen, and also count as the nitrogen fertilizer lost. And how to enhance the nitrogen use efficiency. Uh, so as the acidification effect of selected nitrogen fertilizer. So as we mentioned before, the application of ammonium fertilizer will increase the pH of the will decrease the soil pH, because when the plants absorb one ammonium, these cation, they will release one hydrogen ion from the plant to the soil at the same time. So you can see that the rhizosphere will show the lower soil pH than the surrounding soil. So here have recommendations for the limes used. They can use the calcium oxide water or the calcium carbonate to adjust the soil pH. If you use for these different type of nitrogen fertilizer, different amounts of calcium hydroxide is needed to balance the soil pH. And the three type of process also affect the excess nitrogens not utilized by the plants. And the first one, it have a different form. The micro also will try to different forms process will affect for the nitrogens used, nitrogen fertilizer efficiency in the soil. For example, the microbial effects including the nitrification, denitrification, immobilization, and the chemical reaction including the nutrients ion exchange, the fixations, especially for the phosphorus ions easily have the fixation, and moreover the precipitations or the hydrolysis. The hydrolysis, as we mentioned, for the urea have the hydrolysis and then to form as the ammonium bicarbonate. And the physicals such as littering will cause further the nutrients loss, and maybe it will cause for further contaminations and the runoff, as well as the further volatilization. For example, the nitrogen fertilizer can be released as the ammonium gas or the um, or the carbon dioxide. And several tools are available to help enhance the in efficiency of nitrogen fertilizer. So different compounds will be added into the nitrogen fertilizer, or different nitrogen fertilizer to increase the efficiencies of these fertilizer. The first one is the nitropyrene. The nitropyrin also can help to inhibit the nitrification process. The nitrification process in the microorganisms in the soil. And the urease inhibitor, we already mentioned that they can help to slow down the conversions of urea to ammonium and nitrate, and also help to slow the rate of ammonia productions and help to reduce the ammonia lost into the atmosphere. And also another one is the encapsulation of urea granule, and this one can slow the solubility of the urate and is released to the soil solution. And here you can see that. The nitrogen fertilizer have the hydrolysis, and then they will be released as the available ammonia, and then can be absorbed by the plants or being used by the microorganism. And through the with the help for the nitrifying bacteria, they can convert it as the nitrate form. The nitrate form also can be used by the plants or some microorganisms in the soil. And we need to block this washing away the leaching pathway for the nitrogen fertilizers that can keep or retain more available ammonium and nitrates in the soil. And also we need to block this pathway, this process, try to avoid the formation for the ammonia, try to reduce their loss into the atmosphere. And also the coding we mentioned before. The coding also help to slow the solubilities of some nitrogen fertilizer and control its releasing rate in the soil. That to ensure the release, the availabilities of the nitrogen content in the soil. And here you can see that the mechanism chart of the nitropyrin. Here you can see that the nitrogen fertilizer have the hydrolysis first, and convert it as the ammonium, and have the nitrogen, and then will be released as the nitrate. So they will block this pathway. And for the nitropyrin, the end of the key ways of the nitrogen loss, and the low carbon environmental protection, and the moderate and the continuous nitrogen availability to the crop roots during the whole growth period, and make it have a higher nitrogen efficiency in the soil, and also can help to increase the production, have a good effect on the saving fertilizer and the lowering nitrogen loss. And so brought the nitrifications and from the ammonium to the nitrate can inhibit the nitrations in the soil, and also avoids for further denitrifications and the loss for further nitrogen in the soil system. And here you can see that the ammonium fertilizer with the nitrification inhibitor. The inhibitor will be used as the nitropyrene for the nitrification inhibition. They can reduce the nitrate leaching because for the nitrate formation, this process after the nitrification, the nitrate have easier leaching in the soil because it serves as the anion form. As we said, the cation have an easier binding in the soil environment because, as we know, the organic matter, the soil colloid, the mineral surface are full of negatively charged binding sites. So the cation form are easily to be retained in the soil, and for the anion forms and serve as the nitrate. They are easily to be leaching away and cause for the nitrogen loss in the soil, and reduce the gaseous nitrogen loss. Avoid for the ammonia formation, the denitrification from process, and avoid lower the nitrogen loss and a better nitrogen supply to the soil, and then increase the production. And also the suitable releasing rates for the nitrogen ensure their nitrogen availability in the soil to the plants, and then to ensure have a lot of available ammonium forms nutrients that have a better different elements nutrients, because we can know that the nutrients level for the nitrogen for some specific elements can affect other elements availabilities and efficiencies, and also need to address the soil pH, and also affect the plant physical the physiological effect on the different process. And then here we talk about the phosphorus, and phosphorus fertilizer source and formulation. We have learned for the phosphorus fertilizer in the lecture one. We given the phosphorus as an example. We have learned that there are limited phosphorus fertilizer, and most of them, nearly all of them, come from the phosphorus rock. So with the phosphorus concentrations of phosphorus source is reducing. We need to have a better phosphorus and other nutrients management is the most important things for the sustainable fertilizations. And phosphorus is a fertilizer in the oxide forms. So in the most of the fertilizer, you can see that the phosphorus exists in this form, and not actually exists in the fertilizer materials as the standard form of comparison among different phosphorus fertilizer. And over 18% of the phosphorus source come from the phosphorus rock. They are processed into the soluble phosphorus fertilizer by reacting with the acids. So need to use the acid to dissolve the phosphorus rods that can help to release the available phosphorus nutrients being used as the fertilizers, and a single superphosphate in reacting the raw phosphorus with sulfuric acid, 7 to 9% phosphorus, and also have the 18 to 21% calcium, and also have the 11 to 12% sulfur. And also have another forms is the superphosphorus, and in this form, in this fertilizer, they will use the calcium as the cation, the binding cation, and with one water molecules in these chemical formulas, uh, make it easier to dissolve in the water, and easier to make it use as a fertilizer, and has a faster reactions in the soil, and ammonium phosphorus, and this one because the cation is shown as the ammonium form, and make it easier to dissolve in the water, and also have the diammonium phosphorus, Michelidase have a different concentration for the ammonium content, and as well as the polyphosphorus. The acidification from the nitrogen, as we said, the application for the ammonium nitrogens can release the hydrogen ion, and this process can help prevent the phosphorus or becoming fixed in an available form, because the released hydrogen ion can binding with the other available anion form of the phosphorus, and make it still available in the soil solutions, that when the roots need these phosphorus source, they can absorb these available nitrogens as soon as possible in the soil solution. And relationship of different pools of phosphorus in the soil, and here immediately accessible in the soil solution to make it as a soil solution phosphorus, and high accessibility make it as the surface absorbed phosphorus. The surface absorbed phosphorus, and this part of phosphorus source is available. The plants can absorb it immediately, and some of them belongs to the low availability. They are strongly bonded or absorptive phosphorus. If these available parts can not being used by the plant, and through the further chemical reactions in the soil, they will have a different binding with the other cation. For example, they will have besides in the soil, especially in the acid soil, they are fruits of the aluminum cation. The aluminum cation, when it touch with the phosphorus, they are easily to have a binding with them, and make it to form a compound that is less availability for the phosphorus, and who form the strongly bond or very strongly bond, made these phosphorus unavailable, unaccessible, and unattractable in the soil, and make the phosphorus being fixed in the soil environment. And water soluble type is a single superphosphorus. For example, it have 18 to 20% phosphorus the phosphorus oxide, the triple superphosphorus, and some of them is partly water-soluble types is creek or slow-acting poplite, the acidulated phosphorus rock, and here have a 23 to 26%, 23 to 26% phosphorus, at least one-third water soluble, and also slow-acting type, dicalcium, phosphorus, or the basic slag. Very slow acting type is rock. This rod, the parent form, and a slow acting, slow release, and most of them cannot be used by the soil, and multi-nutrient fertilizers is this in the nitrogen, phosphorus, or potassium. These major macronutrients elements, and also here shows the potassium, phosphorus. This one should be the potassium fertilizer. Is a typo, and here comes the potassium fertilizer source and formulation. The potassium fertilizer is usually described also in the oxide forms, and the standard of comparison among the potassium fertilizer, and here shows the potassium cycle, and always exists in the soil solution form. They are easily to be absorbed by the plants, and also the soil organisms and organic matters can release the potassium into the soil solution, and also the primary minerals are non-extractable or extractable forms of phosphorus for the potassium will affect their efficiencies, their availabilities in the soil. And the potassium chloride is the most commonly being used. Potassium fertilizers in the soil are used in the or being applied in the irrigation water, but when they are being used in the irrigation water, just a very small amount of them is being used or being added, and for the continual irrigations. And the potassium sulfate, it has 14.8 to 53% of potassium oxides. Potassium oxides to 17 to 18% sulfate, less soluble than the potassium chloride. Potassium, magnesium sulfate in these fertilizers can apply for three different essential elements: potassium, sulfurs, and magnesium. And potassium nitrate, as well as the several industrial residues containing the potassium, such as the filtered ducts used as lower acting forms. The filtered ducts, which means that the contaminants or the pollutants being removed, that the rest part have been tested, and also remove the heavy metal in the dust, and only the available nutrients, the essential nutrients part being kept for the fertilizer use. And the utilization of potassium in fertilizer is about 15% to 16% during the years of application. So which means that also a large amount of potassium fertilizer being leaching have lost in the environment, in the water environment. And furthermore, the sulfur fertilizer Sulfur fertilizer must be mineralized to the sulfate anion in order to taken up by plants. So they need to be exist as the anion formed that can be used by the soil and the plants. Then they will exist as the elemental sulfur or the ammonium sulfur, and these sulfur elements will be breakdown by the cyanobacillus and some other soil bacteria, and that being used in the soil environment. And also have other calcium sulfate. We call it the gypsum. The gypsum is the most typical or the main source for the sulfur fertilizers. The sulfur and the calcium bearing materials for the fertilization and the soil reclamations. No effects on the soil acidity, and also hard to handle for this. And single superphosphorus, these type of fertilizer, and also contained 8 to 10% of the sulfur. Ammonium polysulfide is have 45% for the sulfide, and not completely compatible with the liquid fertilizer. And ammonium thiosulfate, it have 26% for the sulfate, and always being used or being added in the irrigation water. And for the sulfate or fertilizer is relatively mobile in the soil. Electrics in the conjunction with cations like the potassium, sodium, calcium, and magnesium. And similar like the phosphorus, because the sulfate and phosphorus also belongs to the anion forms that can be used in the soil and plant systems. So they are easily to leach and have the lost in the soil, and they will have another binding reactions with the different cations in the soil, and also make it also help them to avoid for further cation leaching in the soil solution, because they have a binding with them, and they have to retain them in the surface soil. In the calcareous soil, the sulfur precipitates as the sparingly soluble gypsums and epsomides. And here showing it like this: equilibrium solution, the sulfur's concentrations far exceeds that required to meet the plant requirement. And the subsoil, even in the humid climate, usually are much higher in the sulfate concentrations than the surface soil, especially if there is an accumulation of clays in the B horizons. And here you can see the acidity and the sulfur fertilizers. And here shows that the application or the usage of the sulfurs, they released the hydrogen into the soil. And if the plants take up sulfurs, two hydrogen are consumed in the plants in the reduction to the sulfur in the potent, creating the alkalinity. So because it is as the anion form, when it being absorbed by the plant, the hydroxide ion, the corresponding hydroxide ion will be released, because the plants the plant membrane, we need to reach the electrochemically balanced, and that will increase the soil, the rhizosphere pH, and calcium fertilizer, and the calcium contents depends upon the mineralogies, rainfalls, and seed cation exchange capacity to a greater degree or than for the potassium and the magnesium. And the high rainfall leach the high rainfall leach the calcium, and the plant growth and the consequent cycling. Most plants contain relatively high amount of calcium, continuously replenish the surface where calcium is held on the CC. And the deficiency of the calcium is uncommon because, as we know, that the soil matrix always full of the calcium ion. Low supply of the available calcium is associated with very acid soil, and the correction of the acidity, for example, the addition of lime, the calcium carbonate, also usually supplies more than enough available calcium. So we always use the lime to adjust the pH, and the lime also contains a lot of the calcium. So the soil always full of the calcium ion, and some crops may have difficulty getting enough calcium translocated to plant parts with high demand under certain special circumstances. And so use the lime or gypsum to adjust the pH, and also provide the calcium. And the peanut, they need more calcium ion than the other plants. They need a lot of higher concentration for the calcium, and also for the different nutrients compound formations. And the magnesium, they have a similar reaction or formation with the calcium. They usually exist as the dolomitic limes, and exist as the magnesium carbonate, and quick acting soluble salt, the magnesium sulfur, or the magnesium sulfur exists as the Epsom salt, have the 10% for the magnesium, and also exists as the casearides formed. Deficiency is more common than for the calcium because they have a competition with the calcium. So if the soil is full of the calcium, and it also inhibits the absorption for the magnesium, and behavior in the soil is more like calcium, and sometimes they will also exist in the lime together with the calcium. Here you can see that they will use as the magnesium limestone. So try have one calcium ion being replaced by the magnesium ion. So the magnesium salt are usually slightly more soluble than the calcium salt. Also, they are less tightly held on the exchange complex than the calcium ion. So they are easily to be lost or cannot be absorbed or being used by the plants. Okay, let's take a 10 minutes break, and when we come back we'll talk about the mineral fertilizer source and formulations, and we'll talk about the fertilizer nutrients calculation. 好，休息10分鐘，我哋等陣返嚟再繼續講。 Okay, let's continue. The micronutrients, fertilizer sources, and formulation. And most of the time, you don't need to add the extra micronutrients in the soil um, because in the soil already have the certain amount of nutrients, the micronutrients, and can support for the plant's growth. So then the necessary, the needed micronutrients very small amounts, but are still essential for the growth of plants. And the iron usually applied as a foliar spray in the form of chelates such as the iron EDTA or the irons, the ferrous, the EDDHA. And manganese and deficiency occurs mainly in slightly acid to the neutral soil, both the manganese sulfur and the manganese EDTA. Try to make it easier to dissolve in the soil and the quick acid, and are suitable for foliar or the soil applications. The copper deficiency made most easy to be corrected for a longer period by soil application as copper, sulfur, or the oxides. Zinc usually applied to deficient copper as a foliar spray of zinc sulfate or zinc chelate. And moreover, the chlorine usually found in the soil as the chlorine ion most commonly is applied with potassium in potash fertilizer or with other. The boron as a prophylactic treatment for crops with high demands, soil applications of the borest is advisable. And the next one is molybdenum, right? Required very small amount, the same as nickel. And fertilizer application. So when we use the fertilizer, we need to think which one is the shows in the lowest concentration, because they will the plants in the influenced by the nutrients at lowest concentration as the denominator. The lowest concentration, the lowest nutrients in the soil will affect for all the growth performance, will affect for the productions, and affect for the whole transportation and assimilation process in the soil and plant environment. And here we showed the fertilizer analysis. We usually see the formulas on the fertilizer label. It will always shows 32 or the 10th and 10th like this number. And what does it mean? It meets the percentage for the nitrogen. The first one always represent for the nitrogen concentration, the percentage for the nitrogen, and the second one always shows the percentage for the phosphorus, and in this one show in the phosphorus oxide form. And the last one always shows it for the percentage for the potassium, and in this potassium also shows in the oxide form. So that's therefore we have the commercial analysis and the elemental analysis for the nitrogen, phosphorus, and the potassium concentrations, because when you apply it or when you select the fertilizers, you always see this percentage is for the commercial representation for the different elements concentrations in the fertilizers. And when you apply for these fertilizer on your farms, you collect the sample for the nutrients test. You can measure the concentration for each elements. In these data, it shows not the oxide forms for the phosphorus or the for the potassium, not the oxide forms. All of them show it in the elemental forms. So you need to know the exactly elemental concentration for each elements in the fertilizer. So here you can see that on the fertilizers label it shows 20 20 20, and this one have a the 15 lab weight for the fertilizer. So you can calculate the commercial concentration for the NPK, and also you can calculate for the elemental concentrations for the NPK. And now I teach you how to calculate for these for these concentration. And we can have a simple expression for the fertilizer ratio, and most of the time it show is 10 to 10 to 10, and you can show it easier as the 1 to 1 to 1 all over 10, and make it have a more simple fertilizer ratio in your calculation. And for the fertilizer with 24 to 8 to 16, so you can all over 8 and make it have a simple expression, show it as 3 to 1 to 2, this ratio. So what would be the ratio for the fertilizer with an analysis for the 36 to 18 to 27? So I give you 2 minutes to think about that. So all of them divide 9, you can get a more simple expression. Ratio is 4 to 2 to 3. So here, how to calculate the commercial and for the commercial analysis and elemental analysis for the fertilizer ratio, for the fertilizer nutrients element. And here you can see that it's pressed for the 10 to 20 to 10. It can have a more simple expression ratio to show it's 1 to 2 to 1, all divide 10. And you need to know the weight for the fertilizer. So 10%, which means that is 0.1. So the weight of the fertilizer plus the percentage for the nitrogen, and then you can note the commercial weight for the nitrogen. And then for the phosphorus, in this calculation is calculated for the commercial analysis. And in this calculation for the phosphorus, you can count for is for the phosphorus oxide, and also the same the weight and plus the percentage, and then you can calculate for the phosphorus oxide concentration, and then the same for the potassium, the weight and plus the percentage, for the potassium, and now you can get the concentration for the potassium oxide. And in this calculation, you can get the commercial analysis for the potassium and phosphorus are included oxide. And here for the calculation, you can know that in the 15 lab fertilizer, only 20 of them have the nutrients elements. The other 13 are in the gradients and in these fertilizers. And for the elemental analysis, based on the commercial analysis, you can note the concentrations for the nitrogen, for the phosphorus oxide, for the potassium oxides. And here in the nitrogen, you don't need to pass the molecular rate for the nitrogen. The same elemental concentrations with the commercial concentration for the nitrogen, and for the phosphorus and the potassium, because in the commercial analysis all of them contains the oxide. So we need to calculate the percentage for the phosphorus. So the weight you calculate it from the commercial concentration past the phosphorus the phosphorus percentage in the phosphorus oxide. How can we get these number 0.14 is calculated from the phosphorus oxide. The phosphorus molecular weight is 13.1. Is 13.1 over and 13.1. We have the two. Have a 2 phosphorus is 13.1 plus 2, and then over 13.1 plus 2 and 5 oxygen, and the 5 oxygen 5 past 16. So which means that is 16.2 over 16.2 over the 16.2 plus 16.2 over 114.2. 16.2 over 114.2. So you can get 0.14. So when the commercial concentrations passed these coefficients weight, the coefficients values, that you can calculate the essential phosphorus concentration. The same as the potassium. The potassium is easier, the 0.183. it have a 2 potassium. The molecular weight for the potassium is 39. 39, it have 2. 39 plus 2, and the molecular weight for the potassium oxide is 13.3 plus 2, and 1 oxygen molecular 16. So the total number is plus 2 is 17.8 over 19.4. 17.8 over 19.4. So you can get the 0.183, these coefficient values. So that the commercial concentration past this coefficient value, and then you can get the actual essential the actual elemental potassium concentration. So always the elemental concentration for the fertilizer is lesser than the commercial concentration. The commercial concentration 明唔明啊？知唔知點計啊？
唔明啊？我明嗰個，但係又遮住咗，點算啊？
等，係唔明嗰個0.4、0.83點樣嚟係咪啊？
係啊。
係啦，就呢度咧，你哋要認真聽啦，因為你哋個 future report 嗰度，你哋都要去做咁樣嘅計算嘅。咁樣呢度係教咗大家點樣去計嗰個 commercial analysis，仲有 elemental analysis。因為你哋平時睇到個 fertilizer 咧，咁樣永遠都係咁樣嘅狀態噶嘛。咁樣就你呢個就好簡單計，你淨係知道佢嘅重量啦，然之後知道佢嘅 percentage 即係10就係0.1啦，20就係0.2啦，咁如此類推啦。咁樣你就好容易咁樣知道佢個 commercial 個 concentration 係點，係啲咩嘢。但係喺呢度你計出嚟嘅呢個 phosphorus 就係 potassium， 佢哋係有個陽離子，佢哋係氧化物嘅一個狀態啊。佢哋包含氧化物嘅嗰一嚿，但係點解我哋要去計單獨嘅 phosphorus？仲有 potassium 咁樣呢個單獨嘅 element 咧，因為我哋用唔到你，好似你喺做實驗入邊，你係 lab 2啊 lab 3啊，你用咗 fertilizer， 咁樣你用咗佢，然之後後尾你係咪攞個 soil sample， 攞嗰啲 plant sample 去做 further analysis， 去睇翻個 soil 入邊有幾多嘅 nutrients， 咁樣去睇翻個 plant 入邊有幾多嘅 nutrient。喺呢個 status 嗰度，你去睇到嘅嗰啲 nutrient 嘅 element 係以呢個 elemental analysis 嘅一個狀態，你計咗出嚟嗰個 phosphorus 佢係唔含呢個氧化物嘅，所以如果你用呢個數去，你話我就係用咗咁多譬如10 gram 嘅 fertilizer， 咁樣我咁樣就咁樣計啦，咁樣其實我係有譬如5 gram 嘅呢個，咁我計到出嚟有5 gram 嘅 fertilizer 個 phosphorus 係落到去個泥入邊，但係我點解我度到出嚟個 soil 仲有嗰個 plant 入邊俾佢哋吸收到嘅 phosphorus？個 total phosphorus 點解得咁低咧？咁係咪嗰啲已經係流失咗啊？或者係即係lost 咗咧？咁樣你就會變咗，你係 underestimate 咗你喺 soil 入邊個 phosphorus 嘅 concentration 啦，就變咗可能好大一部分都唔知去咗邊度。咁係因為你喺呢個計算上面就已經係有個問題啦。你唔應該將呢個 commercial 嘅 analysis 呢個 phosphorus 嘅 concentration 直接代入去嗰度去作為一個 phosphorus。係呢個 nutrient cycle 入邊嘅一個計算啦，你應該將佢 convert 咗呢個 elemental 嘅呢個狀態去計算嘅，咁樣就 你由呢個計咗出嚟之後，你知道佢總嘅含量有幾多 percent，有幾多嘅重量，係屬於 NPK。咁咧 N 就唔使再去另外計算嘅，因為 N 係一樣嘅。咁樣佢呢個 N 咧就係代表呢個 elemental 噶啦，因為佢係冇 oxide 喺呢度噶嘛，所以呢個 N 就唔使理佢啦。咁樣然之後咧，去到 phosphorus 嗰度嘅，去到 phosphorus 嘅呢個重量就要乘翻佢呢個嗰個分子嗰個 molecular rate 啊，molecular rate 個 percentage 嗰個，你知道個 formula 係呢個啊嘛，佢個 molecular formula 係呢個啊嘛，即係相當於兩個佢嘅分子係兩個佢個兩個 phosphor 嘅 molecular，即係兩個31，佢個分子質量係31，即係兩個31係分子，咁樣就係62。個分子係62，咁樣然之後 over 你成個呢個 P2O5，即係呢個 phosphor oxide 嘅 molecular rate 就係31乘於2加埋16乘於5，因為呢個 oxygen 個 molecular rate 係16，佢有5個。咁樣佢成個呢個氧化物嘅 molecular rate 就係31乘於2加埋16乘於5。頭先計到係咪142啊？31乘於2加16乘於5，142。咁樣上面係你有兩個嘛，兩個即係62除翻142，就等於0.4366192，咁我哋四捨五入就係攞0.44，咁樣然之後佢計出嚟嘅呢個重量乘翻佢喺呢個即係 phosphorus 呢個 element 喺呢個 phosphorus oxide 入邊，佢其實相當於你佔0.44。呢個比重，咁樣你就知道喺呢一代嘅 fertilizer 入邊，其實得4.4磅係呢個 phosphorus 呢個 element，O 唔 OK 啊？明唔明啊？定係你哋講緊嘢㗎？喂，俾少少反應，俾少少反應我。
哦，原來係咁。
明白係咪啊？因為你哋之後要計數喎。
依家明。
依家明啦，嗬？
明啊，我大概知道講咩。
係啊，咁樣就個 potassium 都係咁樣咯，個0.83都係咁樣嚟嘅咯，個0.83都係39乘於2除翻39乘於2加埋個16咯，咁樣嚟嘅咯。咁你計翻就係0.82幾，咁四捨五入就係0.83。OK，如果你哋明嘅話咧，咁就好啦。咁樣就有一條練習題俾你哋，你哋計下啦。等等我揾人答個 answer，俾10分鐘你哋先。 計完未啊？
未
好。最後俾多2分鐘，夠唔夠？我哋計到55分，然之後我揾同學嚟講下，佢哋計到嘅數係幾多？ 好，計完未？我都計到3。OK，第一題我見到34.485，後面呢嚿呢？後面呢嚿呢 essential 呢個呢？都係呢個係 essential，前面嗰嚿呢？兩 part，第一嚿係OK， 大家係咪都計到啊？其他同學有冇計啊？係咪啊？大家有冇計㗎？係咪一樣條數啊？
有啊，計到。
OK，你哋計到就得啦吓，因為我等陣講 future report 嘅時候，你哋要確保其實每個人
使約到小數點後一個位，定係就4個位就4個位啊？
呢個要視乎睇下要你 keep 幾多個有效數字咯。
但係佢冇講喎。
冇講嘅話就我通常係 keep 小數點後一位，即係3個有效數字。
OK。
係啦。點解題2 essential 唔係17.6 33.2 6 Lannis， 你要唔要講下你嗰個點計嘅？第2題嗰個唔使約返，嗰個係嗰個簡化嘅 especially 個 ratio 就係可以嚇，唔係4624咩？簡化嘅表達就應該係1:4:4。咁啊，但係你哋計數咧，都係要用翻嗰個0.06、0.24咁樣去計。係啦，O 唔 OK 啊？係啦，所以計數嗰度咧都係要跟翻佢嘅嗰個，呢度佢表示係6:24比24，咁樣你個計數嗰度咧，你都係要用0.06，咁你呢度就唔可以弱化喎，唔可以約咗係1:4:4，咁啊唔可以用0.01咁樣嚟去計。OK， 如果大家都識得計呢度嘅話，冇乜問題咧，咁我哋繼續講啦。OK，next。
唔係，即係嗰個commercial 咧就要約翻晒嘅咁樣。
唔係 commercial 嗰度都唔使約翻晒，
即係6都係照寫6:24:24咁樣。
冇錯。
OK。
呢度約係去就叫話俾你知，可以簡化咁樣表示。如果淨係放個 ratio 啊，淨係放個 ratio 簡化嘅表示，就好似呢度個簡化嘅表示，可能特登佢會問你佢嘅嗰個簡化嘅表示可以另外點樣表達啊？淨係放個 ratio 嘅啫，但係放個計數我哋係唔可以簡化嘅。
即係就算係啱啱嗰個 commercial 嗰個填答案都係照填6同埋24咁樣。
commercial 嘅計數都係要用6、24，即係0.6、0.24、0.24。
哦，
係啦，你唔可以用你簡化咗，你咪變咗1:4:4，你唔可以用係0.1係去計個 n，0.04去計嗰個 p，0.04去計嗰個 k 咯，唔可以用嗰個弱化簡化咗個 ratio 嘅嗰個去計翻嗰個 commercial 同 essential。
OK，即係佢係要到話我要你俾個 ratio 我，咁我就先至會出到1:4:4咁樣嘅答案。
係。
OK。
但係計數嗰度就唔可以用呢個。好，O 唔 OK 啊？OK 嘅話，我哋就繼續啦。How variable are crops and needs from year to year? So the crop production change year to year depending on the weather conditions, the human activity, the plantations, the price and this, and the difference. All these factors will affect for the production, and the needs for the nutrients like nitrogen also varies. The every years the needed nutrients level also need to be calculated. So should we apply for the same amount of nitrogen each year? So we need to think about that. We need to calculate that to have a better nutrients management. Considerable year-to-year variabilities in how much nitrogen is supplied by the soil, and the tendencies for the unfertilized yield to decrease slightly over time, and that the amount of non-fertilized nitrogen available to the crops varies greatly from year to year. And it also can separate into two status: the build-up status or the maintenance status. And the build-up status, which means that the soil without the previous fertilizer applications, that before the plantation you need to add more fertilizer to build up the nutrient sink in the soil. And maintenance, which means that after the application, after the soil already have a certain amount of nutrients, and however you need for further plantation, because every year after the plantations, some of the nutrients being extracted by the plants, and after the harvest, and these nutrients will be lost. So you need to put a little bit fertilizer to maintain the level for the nutrients in the soil, and the decrease in the supplies of non-fertilizer nitrogen with time, and the continuous crop production without fertilizer might the soil organic nitrogen. And we also need to consider the efficiency of fertilizer, including the applied percentage, the source. We know that the nitrate and ammonium have and a different source of that will affect their releasing rate, timing. The timing, the before the plantation or the before the harvest, the different stage, different timing have a different absorption rate for the nutrients by the plants. And the nitrogen cycle, and here shows the ratios of fertilizer and the production and fertilizer used by different crops, by the different plants. And that's why we need to calculate for the NUE. We have mentioned these terms before. It it meets the nutrient use efficiencies. And for the nutrient use efficiencies, it have a different part, different type calculations, have partial factor productivity and all the index that can be estimated more easily, and not very precisely because of uncertainties about the actual use of different nutrients by different crops and about crops production statistics. And here shows the different NUE, the nutrient use efficiencies calculations, have partial factor productivity calculations, agronomic efficiencies, and recovery efficiencies, removal efficiencies, and physiological efficiencies. Different NUC term, different nutrient use efficiency terms have a different definition. For the first one, the partial factor productions. Calculate for the crop's yield per unit nutrient supply. That you can note how the inputted nutrients can get how much can receive how many production for the crops, and here always use for the specific crops. You need to calculate the crops weight, fresh weight, and then for the calculations. So all these nutrient use efficiency calculation need to depends on the informations you have. You need to know the how many elements being inputted in the soil, and how many concentrations of these nutrients they retained in the soil, and how much of them being tagged in the plants. That you can have a whole picture for the nutrients efficiencies in the soil and the plant system. That you can use these data for the calculation for the selected items that can use to represent the nutrient use efficiencies. And the partial factor productivity is useful for describing mega trends such as evolutions over several decades of average nutrient use efficiencies in the cereal production in the specific countries or the region. And this calculation is a rough rate calculation, but it can predate or calculate it for a large scale data, not just for one farm, so for more detailed information. Agronomic efficiencies and recovery efficiency is required a record of nutrients input and output. As what I said, you need to note how many fertilizer you add, and how many being extracted in the soil, and how many being detected in the plants, and the removal efficiency for the systems that have been cultivated for long periods where fertility levels have been monitored. And nutrient balance, the nutrient balance can express per unit area rather than as a ratio. Need to use exactly the record for the input and output. And physiological efficiency is an indicator in crop nutrients research and represents ability of plants to transform nutrients acquired from fertilizer into economic productions. And here you an example, show you example how to calculate for the nitrogen balance. So for example, in your lab data, you can know how much of fertilizer being added in, you can calculate, and how much the fertilizer being added in the soil, and then you test the concentration of these elements in the soil, and also you test the concentration in the plants, that you can calculate the nitrogen, the nutrients balance, that you can note the nutrients use efficiencies. And here I give you an equation. It represents for the initial input, the minimum uptake, and the residue of the nutrients you can calculate for the surplus for the nutrients in the soil. And here, firstly, you need to know the initial soil nutrients content first, and then how many fertilizer being added in your farm, and the minimum is the nutrients mineralization. How to calculate the nutrients mineralization? You can use the 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 control forms the plant nutrient after residue and initial nutrients in the control sample and the uptake is nutrient uptake by the plants, and 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 residue is the residue nutrient in the soil that after the examination, after the plantation, you collect the sample from the soil, then you can test the residue nutrients level that you can calculate. You can calculate for the nutrients surplus. And then the input minus the surplus value, you can calculate the utilization. The utilization value over the input value, you can calculate the percentage. And here I give you an example for the carrot plantation. And under different treatment, maybe the first one, the different treatment, they use the different use different materials for the fertilizer, the biosolic, biochar, Chinese manure, and the food waste compost as the fertilizer. And the initial nitrogen input is the same. Initial, because it represents the soil matrix, the nutrients, and then the initial nutrient contains from the soil matrix that you use. The input, which means that you need to calculate the nutrients level, based on the fertilizer label, and then you can know the inputted fertilizer. The inputted fertilizer, for example, you put the fertilizer every week, so you need to count you need to calculate the during the plantation, maybe total 4 weeks, and 1 week you use this amount of fertilizer, 4 weeks, the past 4, and the total amount, the total input for the nutrients, and the minimum then can be calculated through the control without fertilizer usage, and the uptake, which means that is the uptake by the plants. The residue you need to measure the concentrations due can be tested in the soil, and then you can calculate for the surplus, and then you can know the utilization, the input minus the surplus, that you can calculate for the utilization, and then you can calculate for the nutrients use efficiencies, is the neutralization over the input. that you can see that with the treatment for the biosolic have a higher nutrients use efficiency, uh, have a higher turnover rate for this uh, um, fertilizer, which means that when you use these fertilizer, they are easily to be absorbed by the plants. And the nitrogen use efficiency and is a physiological component in the heathlands, evergreen shrubs, and grass. And here shows the nitrogen productivity, and also you can see that in the evergreen shrubs, a little bit higher nitrogen greens efficiency than the grass. And the fertilizer recommendation approaches and the soil test level must be calibrated by using the production response trait to determine the sufficiency level that the fertilization need to based on the sufficiency. So you need to know the sufficiency recommendation, the build-up recommendation, the maintenance. The maintenance so have a different level. The maintenance approach to the fertilizer is applied based on the amount of nutrients removed from the fertilizer to maintain the soil nutrients level. Also, you need to note how much of them being removed from the farm from the field. And the build up approach, feed the soil rather than the plants. 4 to 8 years need to build up because the structure in the soil is very complicated, that you need to long time for them to store for the nutrients and build up healthy systems in the soil. Build up a maintenance approach to the nutrient management that have a different requirements. And here you can see that through the calculations that you can have your fertilizers recommendations, and you can recommend how many fertilizers should be used every year. For example, you can see that you have a desert. The desert soil test should have the requirements for your phosphorus. Maybe you need to reach 14.5, and the current soil test for the phosphorus already reached 13.6. And the build up requires the rate for the phosphorus, it needs 9, and how much of them should be put, and it depends on the phosphorus type and their releasing rate. And through the calculation, they need 81 rate for the phosphorus and you can calculate the years between the application is 4 years, and the annual application also needs this amount for the phosphorus fertilizers. So it needs to take 9 units of phosphorus oxide to build up the soil test level by 1 unit. So you can calculate there are 41 kilograms of the phosphorus over 4 years to bring the soil phosphorus to the desert level. And then each year also needs 20 kilograms per hectare phosphorus oxide per year. And the similar for the potassium calculation also is still have 14.6 below the deserved level. So it takes 4 kilograms of the potassium oxide to build the soil test level by 1 kilogram. So if also the fertilization lasts for 4 years, each year need to add 14.6 kilograms per hectare the potassium oxide if per years. So the calculated maintenance, so the seams of 111.3 millitons per hectare production, the nutrient content, of the 77 kilogram phosphorus oxide and a different 5 kilogram potassium oxide per milliton. So you have the maintenance for the phosphorus calculations and potassium calculations that you can calculate the exactly needed concentration or the amount for the phosphorus and the potassium fertilizer. So any factors also affect the plant's uptake according to any conditions that also will affect the root growth effects uptake and also depends on the plant's response and all other things being equal, such as the compaction, the porosity, the red soil, the water holding capacity, the acid soil, the soil pH, the shallow soil, the not enough space for the roots or herbicide injury, and the littering only concerns on the permeable loads, cation exchange capacity to soil, or the potassium soil testing exchangeable plus solution potassium, and any extraction solution that will provide strongly held cations or weakly held cation in high concentration must be corrected and calibrated on the percentage sufficiency basis like the phosphorus and fertilizer management, the nutrients availability for soil changes with time in the relations to management. Continued harvest and removals of nutrients may result in the deficiency of those that are generally present in high concentration in plants and for which the soil may have limited capacity to provide in plant available forms. And the continued fertilizer inputs of some nutrients may result in a build-up of the nutrients to the point that a previous deficiency no longer exists. So it depends on the build-up status or the maintenance status have a different requirement. And the fertilizer dealer what the farmer using this year. So different fertilizer will affect the efficiencies for the nutrients. And soil test 1 or 2 fields that fertilize the rest of farm based upon the average. And the soil test each year fields every year until you have developed a confidence in your knowledge that what the field should test, knowing that soil test pH, phosphorus, and potassium. And because for the plantation, different plants have different requirements, and also after this year's plantations, next year the nutrient situation, the pH, all the physical chemical properties will be changed. So it suggests to have these measurements and these calculations each year that you can have a clear understanding for your nutrients cycle, nutrients management on your field. And so that's why for the organic farming managements in Hong Kong, and the government also required for the nutrients management every year or half a year that you can clear understanding for the nutrients level, pH level, heavy metals concentrations like this. And the important 4 nutrients stewardships for the fertilizer management. The right source, it provides the plant available forms and a balanced supplies of all essential nutrients, take advantage of various formulations that offer improved efficiency and reduce the environmental consequence. And right rate ensure all the adequate the supply of all essential nutrients to meet plant demand. And the right time to manage nutrients application to match the interaction of crop uptake, soil supplies, environmental risks, and the field operation logistics. The right place consider root soil dynamic and the nutrient movement and manage spatial variability within the field to meet site-specific crops needs and minimize the potential loss from the fields. So the crop it shows the four important components in the nutrient stewardship system. The first one, the right source, help to balance the supply of all essential nutrients elements in plant available forms. And here shows the example, the right source, and to avoid for further loss and different purpose like the horticultural purpose it need a long lasting fertilizers that they will select for the slow acting have the coating fertilizer to control the releasing rate and the right rate apply the supplying power of the soil in a relationship in relation to the nutrients requirement of the plants. So before the harvest, before the mature, that they need to apply for more nutrient because before the harvest they need to absorb before the mature for the flowering and fruiting they need more higher nutrients contents and also effects of rains on the weeds showing potential deficiencies and the toxicities and the toxicity effects of not applying the right rate of nutrients and the right time and the crop nutrient requirements change throughout the growing seasons as the crop grows from vegetative stage and through the productive stage and on the maturity to maturity the right place for the phosphorus and the bending application is more easily to help the plant to absorb the phosphorus, avoid for further atrophizations. So the applications method also very important for the nutrients released. The performance indicator reflects the social, economic, and environmental aspects of the performance of the plant soil climate system, and is a very good balance for the three aspects: the environmental, economic, and the social aspects. That and here is the end for this chapter. And we will take a 10 minutes break first and then we'll come back to talk the rest. 好，我哋10分鐘嘅 break 先。 好，我哋翻嚟。咁我哋而家就講咗嗰個功課先。好，咁我哋講咗個 lab 3先。好，咁 lab 3要做啲咩嘢咧？我哋睇下個 nitrogen fixation 啦。咁樣就前面嗰啲唔使理啦。我哋睇下用唔同嘅 language 去喺唔同嘅 soil matrix 嗰度佢嘅一個 nitrogen 嘅 fixation 嘅一個作用係點樣啦。然之後都要睇下佢個 nodule。咁我哋之前學過個 nodule formation， 特別係呢個 language 呢啲植物入邊啦。咁樣然之後睇下喺我哋種植過程中啦，咁會唔會見到佢個 nodule formation 嘅生成啦？咁樣然之後咧，我哋係有4種唔同嘅 soil。咁樣其實你哋個比較咧，就係會再睇下唔同4種嘅 soil 嘅佢嘅對於植物嘅生長嘅影響啦，nutrient 含量嘅影響啦。咁樣然之後你就睇下佢個 nitrogen fixation，咁樣 nodule formation 呢一 part。咁樣我哋係會有4種泥嘅 CDG 就係黃花沙啦，potting soil、pop soil 糖泥啦、科學泥啦，然之後仲有 river sand 就河沙嘅，係啦。咁樣然之後咧就有唔同嘅 language 俾大家揀嘅。咁我哋有4種唔同嘅豆啦，就係有綠豆、眉豆、紅豆，仲有赤小豆嘅。咁樣豆嘅話咧，咁樣 total 你哋係有60粒嘅豆嘅。咁樣即係開始做 lab 嘅時候咧，你哋要揀60粒嘅豆啦，即係你哋揀一款，唔係所有都做嘅。咁樣揀一款豆，然之後60粒，咁樣你哋有2個 tray 嘅，2個 tray 咁樣就一半一半啦。一半嘅 tray 就係 for 即係一個 tray 入邊有2種泥，咁樣中間隔開。咁樣然之後每一種泥入邊咧，咁樣就係有15粒嘅呢個種子嘅呢個豆啦。咁我哋都係浸咗，然之後有少少嘅發芽就會俾你哋啦。咁樣節省咗你哋前期即係節省咗個失敗率咯，因為以防你哋會有啲唔出到芽嘅一啲豆咯。咁樣然之後咧就係會有15粒、15粒、15粒、10粒，total 60粒咁樣嘅。然之後咧就去種啦，咁就第一日你哋嘅話咧就係要淋水啦、transplant 啦，然之後準備好嗰啲泥啦，因為我哋糖泥俾到你哋咧，未必係好幼細嘅，所以點解你會見到有個 hammer 咁樣就係俾你哋可以揼碎啲糖泥啦，咁樣務求令到佢個 size 係均一啲啦，唔好太大嘅嗰個 particle size。如果唔係，你個糖泥嗰度咧，你啲種子啊攞唔到足夠嘅養分，因為好容易乾啊。佢啲糖泥一乾咧，佢又裂開。咁樣然之後咧，就之後隨住時間嘅種植啦，咁樣你哋每個禮拜都要 take data 啦，咁樣其實同 lab 1、lab 2、lab 3係一樣噶啦。 咁樣你哋呢啲 data 都要 take 啦，就係 leaf colour 啊，呢啲leaf area 就最尾先 take 噶啦，個包 mask 係最尾啦，嗰啲 growth performance 啊，咁樣你哋就會都要喺個種植嘅過程入邊，你哋要 take 個 record 啦。咁樣然之後呢度咧就比較多嘅一個 nutrient analysis 啦。咁樣嗰個就呢度我講咗個 extraction method。咁樣我哋今日咧就係要度啲唔同嘅 elements 啦，個 extraction method 都會有唔同嘅。咁樣首先咧，咁樣 for 個 available nutrient 包括 NPK 啦，咁我哋係用呢個20 gram 嘅泥啦，然之後1:5嘅 ratio， 咁樣再加1 ml 嘅 acid extracting solution， 咁樣99 ml 嘅 DI 水咁樣去 extract呢個泥啦，然之後 shaking for 20分鐘啦，然之後10分鐘嘅一個靜止，然之後 filter 咗之後咧，咁我哋就可以攞嚟做之後嘅 analysis。然之後 pH 嗰度咧，咁我哋唔用 acid extraction， 呢個係個唔同啦。咁樣就直接係少啲嘅，因為我哋直接喺個 Falcon Tube 嗰度去做啦。咁樣就係6 gram 嘅泥，然之後1:5嘅 ratio 啦，即係30嘅 DI 水咁樣 for 個 shaking， 然之後 shake 完之後就唔使去 filter 啦，就直接去度嗰個 pH 仲有 conductivity 嘅。咁樣然之後咧，個 conductivity 就大家之前都做過啦，咁樣佢都係用個 conductivity meter 啦，咁樣然之後唔同嘅讀數都代表咗佢嗰個 dissolved salt 嘅 concentration 嘅 level 去到邊度，咁樣然之後咧，我哋嗰個 TOC 都要去度 soil sample 嘅 TOC 嘅，咁樣個 soil 嘅話就係50 milligram。然之後包喺個石子嗰度，然之後咧去攞去部機去度個 TOC， 要充分燃燒嘅。咁樣然之後咧，咁ammonia 啦、phosphorus 啦，仲有 potassium 啦，咁樣咧我哋都會去打機嘅。咁我哋頭先就 extract 咗個 solution 之後咧，咁樣我哋 filter 之後咧，我哋就直接攞嚟打機，咁樣就係去打CFA 仲有 AS 㗎，係啦。咁樣你又知道佢入邊嘅嗰個 ammonia 個 phosphorus 同 potassium 嘅嗰個 concentration 啦。另外，我哋都要度其他一啲 nutrient element 啦，例如呢個 sulfate。呢個 sulfate 咧，咁樣就係跟翻呢個 step 啦。咁樣我哋咧係用呢個 soil test kit 嘅。咁樣呢個 sulfate 其實可以用 AS 打嘅，咁我哋係想俾大家試到唔同嘅一個測試嘅方法啦。所以呢度你見到我哋有用 CFA AS， 都有用到呢個 soil test kit 咁樣去做唔同一個 element 嘅測試。咁樣呢度咧，咁樣佢都有係一個佢自己帶嘅 calorimeter， 咁樣 through 呢啲reaction 啦，咁樣用佢個 calorimeter 去睇下佢個度數係幾多嘅，咁樣 step by step 咁樣去做，加唔同嘅一個chemicals 啦，咁樣佢就有個 reaction，咁樣大家就可以睇到個顏色嘅變化啦。咁樣就個 sulfate 嗰度除個讀數啦，咁樣大家就有個 range 俾你嘅，咁樣然之後就知道嗰個 sulfate 嘅 concentration 係去到邊度啦，咁係邊個 range 啦。咁當然你哋唔用呢個 concentration chart 嘅話，你哋都可以去search 下，就譬如係 Southern China 啊，或者係香港soil。對於唔同嘅 element 嘅一個 standard 係點樣？因為喺唔同嘅地區啦，有唔同嘅一個呢個 element 嘅呢個要求啊，或者佢個 range 都會有出入嘅。咁 咁樣大家如果係想要將呢一 part 係加入去你嘅 discussion 嗰度咧，咁樣你哋可以篩翻你哋用嘅嗰個 standard 係邊度嘅，咁樣你就唔可以用得太遠啦。即係譬如你用美國嘅一個 soil 嘅 element 嘅 range，佢嘅 requirement 係幾多，咁樣就唔適用啊，因為個 soil 都唔同，soil 嘅唔同。咁樣大家種植氣候各方面嘅唔同，所以大家如果要篩嘅話，最好用啲附近嘅，即係台灣啊、新加坡其實都 OK，咁樣就唔好用得太遠嘅呢個standard 咯。咁樣然之後咧，plant sample 嘅話咧，咁我哋會揀啲組係有啲比較即係生得比較好嘅。咁咧，因為有啲組咧可能疏忽管理啦，咁樣當然個 maintenance，咁我哋都會作為一部分嘅計分標準啦。咁樣喺呢個幾月嘅一個種植過程中咧，咁樣可能有啲組就冇翻嚟淋水啊，或者係各方面嘅原因啦，導致到有啲 treatment 啦，可能就冇植物嘅，咁就唔適用於喺呢個 plants 嘅 sample 嘅 determination。所以喺呢度嘅話，我會揀4組係生得比較好，起碼4個 treatment 都係有植物生長嘅呢個狀態去做呢個 plant 嘅 test 啦，plant sample 嘅 analysis 啦。咁樣然之後收到嗰個 plant sample 咧，咁我哋都會提前去擺咗 freeze dry 先嘅，擺咗 freeze dry，咁樣我哋作出嚟嘅嗰個就確保係一個 dry 嘅 biomass 嘅 sample嘅入邊嘅含量，咁樣去度到咧就會更加準啦。因為如果你用 fresh sample 嘅話，你度出嚟嗰個 concentration，你通常都會係偏低嘅，因為你個水分就已經係會 dilute 咗你嗰個 concentration，你嗰個 nutrient 嘅嗰個 concentration，咁樣你會就 underestimate 咗你嘅嗰個 nutrients concentration 喺呢個 plant sample 入邊。咁樣但係因為時間嘅安排啦，因為大家都喺度 take 緊 data 種緊，咁樣未到最尾最尾一日嘅收 data 咧，咁樣就都好難叫大家提前去收嘅，所以喺我哋呢個 lab 呢度咧，就係會用個 fresh sample 嘅，但係更加好嘅、更加準確嘅係應該用 freeze dry，然之後去做呢個 dry biomass 嘅呢個 sample 嘅 determination 係更加準確咯。咁樣然之後咧，咁樣你哋 dry 咗或者係個 fresh sample，你哋要剪得好碎剪到好碎。咁樣然之後咧就去做個 acid digestion 嘅 acid digestion 咧，咁樣你會見到啦，我哋係要用98嘅濃硫酸啦，然之後擺喺個 glass tube 嗰度，然之後0.5 gram 嘅 plant sample 啦，咁樣然之後咧，我哋要擺去個300度嗰度係燒1個鐘，升溫去到300度嗰度，然之後 last for 1個鐘之後咧，然之後咧就你會見到佢個顏色咧都係黑嘅，咁樣然之後咧你要加之後1個鐘之後咧，你要加3 ml 嘅呢個氧化氫去氧化佢啦，然之後 keep 住再加熱去到300度咯，300度然之後燒7個鐘，咁樣然之後咧你個先至會有個澄清液出嚟，然之後去俾你做個 test 嘅。咁樣然之後呢一 part 咧就要 follow lab 啦，24個鐘頭之後，因為嗰度煲都要煲7個鐘，然之後你要等佢降溫之後，你先至可以做到之後嘅一個 test。咁樣然之後咧就要過 filter 啦，filter 然之後咧我哋 follow lab 先再翻嚟去 kill 翻嗰個filter，然之後大濾去100 ml 嘅 flask 嗰度，然之後再去打機去度到佢個 total 嘅 NPK， 仲有個 calcium， 仲有 magnesium 呢啲嘅 concentration 嘅，咁樣就所以咧，因為太多 sample 啦，如果每一組咧淨係你做你自己嘅 sample 咧，你可想而知有幾多。咁樣我哋要度個 pH 啦、conductivity 啦、TOC 啦、ammonia 啦、phosphorus 啊、potassium、calcium、magnesium、sulfate 呢度有 soil sample，又有 plant sample，然之後 soil sample 唔同嘅 soil 呢度有4隻，唔同嘅 soil 呢度4隻，咁樣 plant 嗰度又有4隻，所以咧你哋係冇可能喺3個鐘入邊可以做得晒你哋自己做嘅所有啲 sample 嘅，所以咧我就係排咗一個table 俾大家啦。咁樣就譬如你哋11組，咁樣你哋咧就係要做呢啲 selected group 咧，就係我哋 total 有一個有14組啦。咁樣我就揀咗第1組、第6組、第10組、第14組，譬如咁樣講。呢4組咁樣佢係種唔同嘅呢個植物啦，咁樣然之後咧佢哋又生得比較好，係確保每一隻 treatment 都有咁好嘅一個生長狀況喺個植物嗰度啦。咁咧就揀嚟做一個 standard 咁樣去俾你哋去做呢個 further test 嘅。咁樣然之後咧，譬如11組，你哋要攞14組嘅呢個 freshwater sand 呢個 soil sample 去度 pH conductivity，然之後又要攞第10組嘅呢個CDG 呢個 soil sample 度呢個 TOC，咁樣然之後又要攞呢個第1組嘅呢個 freshwater sand 去度呢個 ammonia 啦、phosphorus 啦，咁樣然之後攞唔同嘅 soil 去度唔同嘅 elements 啦，咁樣就令你哋每一組每一個同學咁樣其實可以體會到感受到每一個步驟，咁其實係點樣做，要點做去準備嗰啲 sample 啦，點樣去度啲 elements 嘅，咁樣喺你哋做嘅過程入邊啦，咁其實我都會帶你哋去個 equipment room 嗰度，詳細同你哋解釋翻個 CFA 啦、AAS 啦、TOC 啦，仲有個 acid digestion，其實佢嗰個操作嘅原理係點樣啦，係點解我哋可以打機就即刻可以知道嗰個 nutrients element 係點樣啦，點樣去使用啦，咁樣話俾大家嘅。咁就喺你哋嘅 lab report 嗰度咧，就都係 introduction methodology 啦 result 咁樣，就呢度好多 data 啦。咁我等陣會 show 個 data 俾大家睇下啦，去睇下啦。咁樣話俾大家知要點樣去寫啦。咁樣然之後個 discussion 大家要係分清楚我哋個 target 係咩嘢啦。我哋係要比較唔同嘅 soil 對植物嘅生長啦，咁樣然之後，當然你哋有太多嘅 data 啦，咁樣就等陣就住喺個 data 嗰度，我會再詳細再講多一下，要大家點樣去比較下。因為你哋有4種唔同嘅植物啦，有4種唔同嘅 soil，咁樣然之後 effects of legumes planting to the nutrient content of planting medium，咁樣就喺個植物嘅呢度係比較 soil，呢度係比較咩啊？係比較唔同嘅植物，唔同嘅豆嘅生長，係啦。咁啊，呢度個 menu 大家有冇咩問題啊？清唔清楚你哋每個 step 係要點樣做？其實做啲咩？其實有啲複雜，因為呢個 lab 每一次我 run 都要 overrun，可能每一個 section 可能都要去到4個鐘、5個鐘，你視乎每組做嘅一個快慢程度啦。咁樣因為都繁複。然之後多 element 要去度，咁我哋已經係冇話去度到好多嘅 element 啦，即係已經係盡可能咁樣簡化俾大家，咁樣去俾大家體會到每一隻 element 做嘅時候，咁其實個做法係點樣，所以就盡量簡化，但係因為好似一個嗰個 test kit 或者係一個 extraction 咁佢有唔同嘅步驟，咁樣大家要搞清楚咯，即係可能喺呢個 moment 問你哋，你未係好清楚， 但係可能當你哋做嘅時候，或者當你哋寫嘅時候，你哋先會，哎呀，好亂啊！究竟係邊個打邊個？究竟係點樣做咧？咁就頭先我講完嘅話，希望大家翻到去都可以睇一睇，有唔清楚嘅時候先再嚟問我啦。
Vicky 啊，你可唔可以講多次拎去打機嗰度嗰個位？我唔係好明。
上網咪有咯，妹仔。
打機嗰度係前面定後面啊？
14頁左右。
呢度
係。
OK，咁就係、嗱，由呢度開始啦。咁由呢度開始，咁我哋見到我哋後面個 table 嗰度咧，其實有唔同嘅 element 啦，有唔同嘅 element 啦。咁樣就有 pH 啦、conductivity 啦、TOC 係燒嘅，TOC 係燒嘅，就直接磅重攞去燒就係啦。咁啊 pH conductivity 咧，咁樣就係我頭先嗰個方法嘅右手邊嗰個，嗰個太陽嗰邊啦。咁樣佢個 extraction method 咧，同後面嗰啲又唔同嘅。咁呢個咧就淨係會用到呢度。咁樣淨係一個 Falcon tube，唔使 filter，淨係6g 30ml 嘅 DI 水 extract 完靜置完，你就可以直接攞嚟度 pH 仲有 conductivity。嗱，呢度就係 for pH 仲有 conductivity。然之後咩要打機咧？就係 ammonia、phosphorus、potassium。咁樣 calcium、magnesium 呢啲都係要打機嘅，呢啲打機嘅。咁呢啲打機嘅 sample 點樣去準備咧？打機嘅 sample 咧就係呢一邊啦，20g 嘅 soil， 然之後咧1:5嘅 ratio 啊，即係我哋要加100ml 嘅一個 solution 去 extract 佢。咁樣1ml 嘅 acid extracting solution， 然之後99ml 嘅 DI 水，咁樣同樣地 shake 20分鐘，靜置10分鐘。呢個時候呢一 part 我哋唔可以就直接咁樣，我哋係要 filter 咗之後，過咗 filter paper， 然之後咧嗰啲過濾液啦，我哋先至可以留嚟做打機嘅。打機係打咩啊 ？AAS 打嘅就係打機 ，AAS 打嘅係 potassium、calcium、magnesium。咁樣 AAS 嗰度咧係會換唔同嘅燈管。咁樣每一條燈管咧就度一隻 element， 咁樣你哋打完 potassium 就換一隻燈管，就再打 calcium， 打完 calcium 再換一個燈管就打 magnesium， 咁樣然之後 AAS 就可以度到呢一 part 嘅呢啲 parameter 啦。咁樣 AAS 就係啦 ，AAS 咁樣就係打嘅呢一部分 AAS 嚇，然之後 CFA 打機嘅就係頭先同樣地 filter 咗嘅嗰啲 solution， 我就可以攞嚟打呢個 ammonia， 仲有 phosphorus，ammonia 仲有 phosphorus。咁樣呢度又係打機嘅，咁樣佢同時一打出嚟咧，佢就可以有2個 parameter 出嚟㗎啦。同時打完就係有 N 同 P 同時出嚟嘅，咁樣呢度。就係呢度，所以你哋左邊嗰個月亮嗰個方法 extract 咗出嚟嘅嗰個 filter 咗嗰個 solution 係要 for 2部機 for 5隻 element 嘅一個打機嘅 determination。咁樣 sulfate 咧就唔同啦 ，sulfate 咧就係要用個 soil test kit。soil test kit 咁樣個方法咧就喺呢度。list 咗 step by step 咁樣 list 咗出嚟啦，就要跟翻呢個咁10幾步嘅方法啦。咁樣然之後加晒所有嘅一個加晒所有嘅呢個chemicals 啦，加晒 chemicals 啦。然之後咧，你就再等佢反應，等佢反應之後咧，佢呢個 kit 入邊咧就有一部係 color remitter。咁樣就睇到個變色嘅，睇到個變色咧，然之後你再擺落佢個機嗰度咧，佢有個 reading 出嚟。咁樣呢一個咧就係特別另外自己嘅方法，自己另外嘅方法去度呢個 sulfate。咁樣就係呢度 soil sample， 同樣地 plant sample prime sample 嘅話咧，就係要做 acid digestion 啦。咁樣你哋做完 acid digestion，因為要 follow lab 24個鐘頭之後先可以 follow 翻嚟 follow lab。嗰支 filter 咗嘅嗰支 solution 咧，就直接去打 CFA 仲有 AAS 啦，就係咁樣。所以有 soil sample 又有 prime sample 嘅，想唔想像到？
想象唔到。
想像唔到。但係嗰啲步驟有冇清晰少少？唉，我放個 video 俾你哋睇下啦。但係我之前拍嘅，但係唔係 for 呢個 course
好明
嘅。
嘅，呢個係咪我哋要翻嚟做啊？
呢個
係啊，
而家
係啊，定係到時即係
冇啊！你而家邊有得翻嚟做啫？咁樣到時候補 lab 嘅時候補俾你哋嘅時候先翻嚟做咯。
哦，
係啊，所以但係你哋冇做嘅情況之下，但係你又要寫咯。我俾個 video 你睇一睇啊！我俾個 video 俾你哋睇望一望啦，但係就唔係 for 呢個 class，唔係 for 呢個 course 啊。等我開埋個聲先得啦。唉，點咁嘅？等陣啊！
我 lab menu 去教大家，就會
聽唔聽到啊？
大家喺個 web market
有冇聲啊？
普通嘅街市
聽到啊！
喺呢個菜買咗，所以咧我哋就要係沖洗咗之後咧。
嗱呢個咧就係你哋嗰個 prime sample 嘅一個 treatment 啦。prime sample 嘅 treatment 咁樣你哋唔會，即係你哋要畫個葉嘅 shape 㗎嘛。咁樣你哋嗰葉咧嗰個 leaf area 嗰個畫完之後咧，咁樣然之後咧應該就係要 fresh sample，然之後攞嚟咁樣去做嘅。但係就我講咗啦。我講咗就因為呢個 lab 咧就冇辦法用到個 dry sample、freeze dry 嘅 sample，因為你哋仲要畫個 leaf area 啊，咁樣然之後即刻收咗，然之後又即刻度啦，咁樣又冇辦法做到呢一步。如果唔係嘅話咧，用個 freeze dry 嘅 sample 去做個 analysis 係更加好嘅。咁樣你會見到咧就 freeze dry 嘅話咧，就會將佢磨碎啦。咁樣要熱到脆之後咧，度咧，一般 freeze dry 佢一個禮拜咧，咁其實佢就大家有冇食嗰啲乾咗嘅嗰啲蔬菜、蔬果片？咁啊，其實都係 freeze dry 呢個嚟去做，咁會出嚟嘅成品咧，就大家食 freeze dry 啲凍乾嘅呢啲蔬果片嘅狀態一樣嘅，一捏就碎啦。咁通常一磨咧，佢就變粉嘅。咁然之後咧就放零2g 咁樣嘅葉啦，去個 tube 嗰度。然之後我哋等佢做個 acid digestion 啦。
咁樣 soil sample 咧，其實同樣嘅處理 但係我濕嘅話就好似之前我提到咁樣 plant tissue 佢含有越多嘅水分就
係啦，
我哋
咁樣
會將
soil
啲
sample 咧
soil
，soil sample 我哋喺呢個 lab 入邊咧都係
點解唔
冇辦
open
法
dry 咧？
用
呢個問題
air
咧，咁
dry
我
到。
哋其實
咁我之前我哋
喺
教
soil
咁樣 soil
environment
sample 嘅 treatment
嗰
應
科咧，
該 air
我哋
dry
都
咗
已經
咁先
學過
代得最
相
準
關
確啦。
嘅
咁樣但係我哋呢度因為係最尾一日即刻收最尾一日嘅 data， 之後我哋係冇提前一個冇足夠時間提前一個禮拜俾大家去 air dry。咁樣所以呢度度出嚟咧，其實都係全部都係佢嘅 fresh way 嚟㗎。
或者好不耐會 collect 到鹽。咁
咁喺呢度係 acid
將呢
digestion。
個
咁 acid digestion 咧，你會見到係呢度係有兩個 sample，呢個係縮，soil sample 呢個係 plant sample。咁喺佢呢個course 入邊咧，你淨係 plant sample。
加咗落去咧，因為濃
加
硫酸係具有就好危
之後
險
咧，
嘅，所以我哋
再
做呢個 acid digestion 咧，仲有加硫酸呢個步驟咧，我哋係必須要喺個 group 嗰度做進行嘅。
個氧化氫
等陣
之後咧，
acid digestion 啦，我哋講
黑色
下點樣
變
加
成透明，
嗰個硫酸落個 sample 嗰度。首先我哋係加6 ml 嘅6 ml，咁樣即係我哋要準備一支5 ml 嘅排斥啦。
咁樣
準備一支1 ml 嘅排斥嘅，
先至可
我哋就可以逐次咁樣加6 ml 硫酸。
測試啦。咁樣 soil sample 點解要咁樣做咧？soil sample 做 acid digestion， 我哋度出嚟嘅都係一個 total 嘅，第一個 total 嘅 nutrients level。咁平時你就咁樣 shake 出嚟攞出嚟嘅嗰個 nutrient available 唔係 total。我哋有 acid digestion 咁樣去做出嚟咧，就係呢個 total form
就可以。
咁樣，但係你呢一步咧，
呢個 acid digestion
呢就係 acid digestion 咩每一個
燒㗎啦。
佢咧
大家見到呢度
加
燒緊呢個 D sample
咁樣佢呢度可以
已經
夾一個
係去到300度㗎啦。
升溫，
咁樣就跟翻我哋 lab
持續幾耐
啦。佢入邊已經係咁嘅
都
黑色嘅，
入邊係黑色。
咁樣係點樣
黑色啦，然之後咧你即刻加個氧化氫咧，佢就會變呈星，
可以
變呈星啦，然
嘅嗰個
就
狀態。
燒7個鐘之後再攞。
NP 每一種
呢度咧就係我哋 filter 完咗之後，你話 soil sample 啊，plant sample 啊，打機啦，呢個係 CFA 嚟。
用啱先 acid digestion 完咗之後咧，攞個 volumetric flask 定量去100 ml 之後咧，我哋就係可以攞啲細嘅 rat 啦，然之後擺喺呢個 auto sampler 嗰度。
好細
係有個窿㗎。咁我哋咧係每一個 sample 啦，大概係
夠大
10 ml 左右嘅，咁樣 test tube 擺喺呢度。咁樣咧，其實就可以 auto run 之後咧，呢部機其實我哋係叫做 CFA 嘅。CFA 就其實係 continuous flow analyzer。我哋主要係攞嚟度 N 同 P 嘅，因為 acid digestion 你會可能有啲同學就會覺得，點解我所有嗰度學嘅其實攞水 extract 咗之後就可以度到 N 同 P NPK 嘅，咁一啲點解呢一次喺organic farming 呢度學嘅，我仲要再多一步去做 acid digestion 咧？因為咁樣我哋其實兩種方法 extract 出嚟嘅嗰個 NPK 係唔一樣嘅。由呢種方法 extract 出嚟嘅 nutrients level， 我哋呢個 essential element 我哋係叫做 total 嘅 NPK 啦。所以咧就你啲 sample 放喺度啦，咁樣我哋個
我斷咗線啊！你睇到幾時冇咗啊？
好似講唔清楚。
哎呀，我而家連唔到，我要 reboot 部機。大家等我一陣啊！
但係喺 YouTube 度揾到你條片嘅喎。
揾唔到嘅，揾唔到㗎。你冇我條 link 啊？
有啊，
揾到？真係㗎？
有啊，我 send 俾你。
係 set 咗喎，我係點會咁㗎？我唔係 set 咗係
我
唔係
send
for
俾你
public 啊？
Payment analysis 啊嘛，攀面啊嘛。
頂！哎呀哎呀哎呀！唔得唔得唔得！我要點解咁你就咁 search 都 search 到？你就咁 search 到啊？
唔係我 search，但係有人 search 到。
竟然
係啊，我 send 咗俾你啊，WhatsApp 度。
有人 search 到？點解會咁㗎？我明明 YouTube 嗰度係 set 咗嗰個叫咩嘢啊？公開㗎嘛，咪就 search 唔到嘅咩？重新開機緊。哎呀，點解會斷線？大家等我一陣啊，我開緊。就咁揾都揾到？
冇啊，唔係揾唔到咩？
吓？揾唔到定揾到啊 ？Lennis 又話就咁揾都揾到。我 set 咗個 upload
我
嗰
揾唔到咯。
個揾唔到應該係正常噶嘛，係嘛？唔好嚇我，唔好嚇我。等下等下，我開埋嗰個網頁先。因為咧，我係另外一個 course 就係 for 佢哋嗰個 test，咁我係有錄嘅。咁樣你話上嗰一堂嘅同學，有嗰條 link 咁樣我就信。係啦，咁我都有同過大家就講，如果我即係呢啲 video 啊，無論我 upload 上 Moodle 啊，或者係 upload 喺 YouTube share 呢啲 link 咧，咁樣都係 for 呢個課堂嘅使用嘅啫。咁希望大家就唔好流傳出去嘅，係啦。咁就我播埋嗰段片先。大家睇到邊個位啊？
實驗啦，因為個疫情
打機嗰度
關係
CFA
翻嚟學校，可以啦。filter 完咗之後，
睇到邊度
部機其
停咗啊？
實我哋係叫做 CFA 嘅，CFA
呢度睇到未啊？
continuous flow analyzer，我哋主要係攞嚟度 N 同 P 嘅，因為 acid digestion
之後做即係做嗰個 lab report 咧，我覺得睇翻條咁點算？
做之後就可以度到。
但係呢條片唔係 exactly for 你哋用咯。
點解呢一次喺
即係等陣先。
我跟啲翻明呢度學嘅，
因為嗱
我一步去做 acid
等
digestion，因為咁樣我哋其實兩種方法 extract 出嚟。
係咯，不公開列出噶嘛，你應該唔會就咁 search 到我嘅。如果嗱，我就想問下你哋啦，因為呢段片咧就唔係 for 呢，
係泥嚟噶。
吓？係 field trip 係泥？
係啊，係泥有關嘅嗰個。
係泥有關？你等陣可唔可以 send 俾我睇下？
send 咗俾你 WhatsApp。
我可能個 setting 有問題，我要咩啊？我要再搞一搞。
可能真係傳到咧。
係喎，呢個係呢個係 Soil 㗎係咪？你哋做過㗎嘛？哎呀，呢個係 Soil 㗎。咦？係呢段啊？唔係啊，係呢個啊，係咪啊？算啦，呢個先至，等陣我再睇一下。你自己揾嘅定係人哋 send 俾你㗎？
應該係 send 到啊。
係咯，應該係 Organic Farming 嘅嗰邊嘅同學 send 出嚟，唔可以㗎嘛。
咁我哋都有得參考嘅，呢個好事嚟。
唔係我就問你哋想唔想要攞嚟參考咯？但係唔係完全 fit 到你哋，唔係呢一科拍嘅。但係如果你哋話想參考嘅話，我可以擺上去俾你哋參考。你哋需唔需要？但係因為呢段片唔係拍嚟 for plant nutrition。
因為你俾我哋睇嗰個，佢用嗰啲機係即係通噶嘛。
係啲機係通嘅，啲 step 係有啲唔同嘅，只係一部分咯。我係驚誤導咗你哋咋，因為我驚我擺上去咧，有啲同學冇，譬如冇上呢堂，冇聽我講過 lab menu。唔知係點樣，然之後佢以為睇翻個 video 咁樣就係咁樣做，我驚係誤導咗一部分嘅同學咋，所以我冇擺上嚟。咁樣呢度我點解播個片俾你睇咧？係因為你哋話好難想像，咁樣我就有埋段片加埋我嘅講解。但係如果我單純將段片擺上去，你哋作為後期，即係你哋講緊可能1個月之後先至做呢份功課，等到時候會有同學話吓，點解同嗰段片唔同嘅？我都係唔擺啦，係啦，我都係唔擺啦吓。咁我就住嗰段片咧，再同大家再講下。咦？段片而家起碼都可以跟翻。寫埋時間段啊！我擺上去，但係係啦，淨係課參考，就唔係完全跟呢個 video，因為呢個 video 係 for organic farming，係會有共通嘅地方。寫埋時間段，我會考多功夫啊！係啦，淨係參考打機嗰一 part 咯。我等陣，一係我睇下剪一剪佢啦。我睇下剪一剪佢，淨係俾嗰片段俾你哋啦。好，
你可以 set
咁
timestamp 喎。
咩嘢啊？
你可以 set timestamp 喎喺條片，因為你可以編輯條片啊嘛。你喺下面即係好似有個功能咧，係可以 set 到 timestamp，你可以將嗰條片剪咗一段一段嘅。
哦，好啊！我等陣搞下，我嘗試下。咁我再講埋啦，咁樣就都係用呢部 CFA 呢部機去打 N 同 P。咁我呢段片其實有講解咗一個嗰部機嘅一個操作，咁我呢度唔重複啦。如果我等陣會 release 呢段片嘅話，我呢度就重複咗。咁我講咗咁樣個 reaction，咁其實點樣？咁樣然之後呢度係咯，我講咗幾部機嘅，呢度 CFA 呢一部機，咁樣然之後 AAS 呢部機，咁樣然之後呢度係有佢靠嗰個燃燒嘅，咁我呢度係有燈管去換嘅， 呢個燈管係
見到
換嘅。
佢開咗之後咧，其實
係啦，因為
喺
換呢條
呢度咧就會
燈管，呢度你見到佢唔同嘅燈
抽
管
sample
打唔同
入去啦，
嘅 element。
然之後呢咁我哋係啦，
呢度
所以
就寫住
每一
唔同
隻
element。
呢個咁我哋抽佢照咁樣，然之後就
係啦，咁我可能淨係後面呢一 part 咯，打機 acid digestion 嗰度，我睇下剪到幾多俾大家。咁呢度淨係一部分嘅啫，呢度淨係一部分。呢度淨係當會 report 麻煩。OK，咁就係一部分啦，一部分啦。咁我會等陣剪下條片，睇下可唔可以令到大家知道發生咩事啦。盡量令到大家知道發生咩事啊！咁呢個 lab 其實都重要嘅。咁樣之後如果可以翻嚟上堂咧，咁我都會補翻個 lab 俾你哋噶。咁就係咯，呢個 lab 會可能之後有啲同學係 FYP，咁就都會用到嘅，都會用到嘅。O 唔 OK 啊？有冇啲 idea 知道發生緊咩事？咁呢度咧就係頭先個 CFA 打嘅嘢，咁呢一 part 咧就係AS 打嘅嘢，咁呢個就係個 soil kit 要去用到嘅嘢。咁樣然之後去到個 data 嗰度，我用咗好多時間喺呢度。我 field trip 嗰度都未講。data， 哇！呢個 data 就多咯。呢個我就係你哋嗱，呢度有好多 data， 有 group data， 有 class data。首先係即係如果我可能有啲位漏咗或者係唔清晰嘅，咁樣到時候你哋就話我知啦，因為我可能會又有啲 details 位未係執得好好，咁樣然之後咧呢度就個當你哋組，大家每一組都係用呢個 group data 噶啦，咁我唔會再分你哋8組咁樣，8組有唔同嘅豆咁樣，再俾一隻 data 你哋冇啦，咁樣你哋咧每一組嘅 group data 都係用呢一 set 噶啦，咁啊 red bean 啦，咁樣你哋揀嘅豆就係紅豆啦，咁樣然之後咧個 leaf color 係咁樣啦。咁樣 leaf size 呢度就係嗱，當你哋喺最尾一日咧收咗嗰塊葉咧，咁樣你哋要喺呢個格仔紙嗰度咧，然之後畫翻出嚟計翻個 area。咁樣呢度佢就幫你寫咗抹翻低，咁樣計晒呢個 area 大概係幾多啦？呢度係成個 treatment 入邊嘅植物嘅葉面嘅葉面積就係咁多，咁樣你要計翻個 total 啦，計翻個 average 啦，咁樣然之後好似佢第4個 treatment 呢度，第4個 treatment 即係河沙，呢個係黃花沙 potting soil、pop soil 呢個就係河沙，咁樣就係冇葉嘅，即係死晒。點解容易河沙死晒咧？因為河沙你大家知道佢係 sand，咁樣佢 evaporate。嗰啲好快，咁樣就你幾乎每一日你1、2日都一定要淋水。咁樣如果你哋係隔耐咗冇淋水咧，咁樣佢哋啲植物就好難維持得到咯。特別喺河沙嗰度。咁樣呢度咧就係個 average 個 leaf area 啦。咁樣你哋嗰個 graph 就自己要 plot 過啦，唔好 copy and paste， 唔好 copy and paste， 直接照抄我嘅呢個 table 啊 graph 啊，你哋自己 plot 過啦。咁樣如果唔係，我扣分下。然之後咧個 dry biomass 係分咗 shoot 同 root 嘅。呢個你會見到咧，好奇怪嚇，點解佢冇葉面積，但係佢又有個 dry biomass 咧？即係咧，佢係冇葉剩咯，就得條框喺度。 嗰啲葉落晒，啲葉落晒或者係乾晒，得條框喺度。但係即係嗰條絲都仲喺嗰度，所以你見到咧呢度4個 treatment 咧都係有嗰個 dry ball mask。咁大家搞清楚個 sample 1、sample 2、sample 3、sample 4係咩嘢，就跟翻佢呢度呢個 sample。sample 1CDG sample 2係 potting soil，sample 3係 pot soil，sample 4就係剩低最尾嗰個 fresh soil。咁樣你要見到呢個啱種落去 transplant 嘅時候，咁樣佢嘅每個週期嘅一個變化啦，係啦，去到最尾嗰個 root 嘅時候，咁樣佢嘅 number of nodule， 咁佢又數最尾一日嘅時候，你掹翻出嚟，你見到個 root 嘅嗰度咧會有 nodule 嘅數量啦，咁樣然之後呢個 nodule 個數量啦，然之後呢度跟翻 leaf area、dry ball mass 都係最尾一日先至會有㗎。然之後 sample 2就係 potting soil 咁樣，然之後佢有個對應嘅圖片啦，生長嘅狀態啦，咁樣然之後咧呢度咧就係一個係呢個係 pot soil， 呢個 pot soil 個 nodule嘅 formation 啦，咁樣然之後咧呢個就係佢嘅 leaf area 啦，咁樣然之後你見到佢呢度佢個 data 係冇 leaf area， 但係佢呢度我見到好似仲呢一塊應該係隔離嘅。嗱，大家留意翻啦，呢塊同呢塊佢哋係兩格，佢係去到後期先至係死咗乾晒。呢啲咧係佢隔離㗎，呢啲植物唔係喺佢呢度㗎，係佢隔離嗰一盤，佢隔離嘅嗰一兜嘅科學泥係生咗喺佢隔離，咁樣呢一塊咧係佢隔離嘅，所以呢度咧你見到淨係得一啲框啊，乾晒。咦？呢個就係一個 group data、class data， 漏咗。呢個 class data 嗱，呢個就係 group data 啦，然之後咧個 class data， 等我一陣。係，呢個就係 class data。呢個 class data 就係跟翻個 table 嗰度，然之後度出嚟嘅一啲 data 啦。咁樣然之後咧，你會發現有好多 data。然之後點樣去 discuss？咁樣好似譬如我第一個 reflective question， 唔係喺個 result 嗰度。首先喺個 result 嗰度，大家要就住唔同嘅 element， 咁樣就要 pop 個 graph 出嚟。首先要分開 soil 同 plant 啦，講咗 soil 先，咁樣然之後就住唔同嘅 element， 即係譬如首先你 pH， 然之後你 pH 咪有唔同嘅 species， 唔同嘅嘅 plant， 眉豆、紅豆、綠豆啊呢啲赤小豆咁樣，然之後喺呢啲每個豆入邊，其實佢又有4種唔同嘅 soil， 所以其實係相當於一個 graph 入邊，你係有好多條 column 去代表住你呢個 parameter， 每個 parameter 要單獨講。然之後去到個 discussion 嗰度，我要有2條 reflective question。reflective question 第一條係問你唔同嘅 soil matrix，咁樣你呢度呢個時候 你咁多 data，你個 target 係要比較唔同嘅 soil matrix 對於植物嘅一個影響，所以你比較個 target 係唔同嘅 soil。咁樣第二題係話咁樣種植唔同嘅 language 對於個 nutrient 嘅影響。咁呢個 target 係咩嘢？呢個 target 你要比較唔同嘅 plants。咁但係點樣去 plot 個 graph 係可以令到個讀者更加知道、更加明白你嘅嗰個想表達嘅嘢，你想表達嘅 target 係咩嘢？咁就要視乎你點樣去 plot 個 graph，點樣去解釋你幅圖啦。因為好多時候，你無論係做你自己 FYP 或者你做任何嘅呢啲 experiment，好唔會淨係好似你哋之前咁樣，好似 soil 啊或者之前嘅一啲實驗咁樣，淨係得咁少嘅 data。咁啊，當你哋收咗好多嘅 data 翻嚟嘅時候，話又有 N 又有 P 又有 K， 又有唔同嘅 element， 又有唔同嘅 soil， 咁咧呢個咁大 scale， 咁一大 lot 嘅 data 點樣去分析？呢個就係考大家點樣去做個 data analysis， 去做呢個 lab report 嘅一個能力咯。呢個都視乎翻都會對於你哋之後嘅FYP 啊，或者你哋之後嘅一啲學習係好重要嘅。即係譬如你自己一個 FYP， 你要比較唔同嘅 treatment， 比較唔同嘅植物，然之後你收咗好多 data， 但係你點樣去喺你個 report 嗰度表達翻出嚟？呢個好重要，清晰明確咁樣去展示翻你要表達嘅一個重點。係咪冇乜頭緒啊？可能要到你哋做嘅時候，你哋就會發現，哦，究竟要點樣去 plot 個 graph 咧？咁樣嗱，data 就咁多，係啦。咁樣個 submission deadline 咧就係未有咁快嘅，咁樣就係4月14號啦。唔係4月13號嘅夜晚11點59。
4月12號咧，4月12號有個 Caroline 嘅嗰個 individual 好大份嘢要交啊！
但係我呢個已經而家 release 俾你哋，然之後仲係 group 嘅。我而家所有嘢已經 release 俾你哋，即係我冇話你哋2個禮拜要趕起我同佢嘅嗰一份啊嘛。呢個仲要係 group 嘅喎，呢個仲有28日喎。你而家同我嚟講，仲要唔係 individual 嘅喎。我已經係褪得，你自己睇下我個 timetable， 我已經係2個禮拜交一份啦。係啊，我2個禮拜交一份，仲要係 group 嘅添。我相信你哋 OK 嘅。咁然之後嗰個 group 個 class data， 我呢度仲有一份未 upload 嘅，咁我等陣會再 upload 上去。咁樣就係呢一份 upload 漏咗。好，咁啊 lab 3呢度有冇咩問題啊？有冇咩問題啊？
冇啦。
OK， 冇，咁我哋去下一份 future report。唉。因為我哋冇得去 field trip 啦，咁樣然之後咧，但係我哋又要完成呢個 future report 啦，咁樣我就會俾一啲 data 俾大家，咁樣而家話俾大家知要做啲咩嘢啦。咁樣通常咧呢個咧係要你哋我哋係有3個field trip 咁樣嘅，咁我去3個唔同嘅西去比較唔同嘅運營嘅機構啦，對於個 nursery 嘅一個管理，關於 nutrient 嘅一個 management 係點樣啦。咁樣然之後咧，去到嗰度咧，咁其實大家就要去，我會俾展示俾大家 睇咁樣佢哋嘅一個運作啦，咁樣佢哋點樣管理佢哋啲 fertilizer 啦，咁樣你哋係會影到相㗎，咁樣你哋會影到佢哋用嘅嗰個 fertilizer 係邊一款啦，咁樣佢嘅 nutrient 含量係點樣啦，咁呢度咧就會要你哋做一個 calculation 嘅，咁我頭先上堂講嘅嗰一 part 啦，咁希望大家都已經明白點樣去計啦吓，咁呢個要喺你嘅功課入邊去計嘅。另外咁樣，然之後按西嗰度咧，咁樣其實你哋咧就我之前嘅 lecture 有講過點樣去睇個 nutrient deficiency 啦。咁樣喺我哋嘅參觀嘅過程入邊啦，咁樣你哋都可以睇下邊啲邊啲植物已經係顯示咗個 nutrient deficiency 啦。咁啊可能就判斷喎，跟翻我哋之前嘅一啲 guideline 啦，咁樣一啲 lecture notes 啦，去判斷翻究竟佢係因為邊一種營養嘅缺乏導致佢有呢個咁樣嘅症狀咧？咁樣按篩嘅時候咧，咁你哋其實都可以問下我啦。咁樣，但係我唔會俾太多嘅 tips 俾你哋。咁如果咪全部係問我咁樣我會話俾你，即係你唔 sure 嘅時候，你可以問下我，咁我都會答你嘅。咁咧唔好話棵都行嚟問我，佢話呢棵係唔係啊？咁樣有冇 deficiency 啊？係邊一種啊？咁我冇辦法答到你咁多嘅。咁然之後咧，呢個第二題啦。咁樣你哋係要揾6隻 species in the site。咁即係如果我哋係去3個 site 嘅話咧，咁樣就係3、6、18棵嘅。咁就然之後咧，咁樣 what the different type of plant nursery 啦，咁樣然之後個 layout，咁呢一 part 咧，因為我哋冇自己真係去啦，咁我會俾一啲 background information 俾你嘅，然之後你哋再跟翻我呢個 background information 去答翻呢一題咯。咁樣呢度咧就係呢一份 future report 3題嘅啫，3題嘅啫。咁樣然之後咧，我俾個 data 你哋問一問。俾你哋望一望，好啦，咁樣呢度咧，我哋係寫2個西就得啦，咁我就冇3個西，3個西好似有啲太多，所以我就揀咗2個西俾你哋去做呢份功課啦。咁樣呢度咧就係、就當你哋去咗呢個曹公潭個 nursery 啦，咁樣佢哋用嘅係呢隻肥，咁樣其實都清晰嘅，咁樣你就跟翻呢個。就計翻呢度有晒重量啊，有晒個 NPK 嘅嗰個 percentage 啊，個 ratio 啊都有晒啦。咁樣然之後你哋就去計翻個 commercial，仲有elemental 嘅 nutrients 嘅含量啦。咁樣然之後呢個就係 Rooftop Republic 嘅用嘅嗰一款，OK。咁樣個 label 就喺呢度嘅。咁樣然之後咧，咁呢度個你哋就揀6棵就夠啦。咁我呢度俾嘅唔止6棵，咁以防萬一有啲同學就話：哎呀，我個相睇唔清啊，咁樣或者點樣，我係俾超過6棵，呢度應該有12棵嘅。咁樣你哋喺呢度入邊。我已經俾晒嗰個 species 俾你哋啦，係啦。咁樣然之後，我俾12棵你哋噶，你哋就喺呢度揀6棵去寫。咁樣有咩症狀啊？咁樣然之後呢隻 nutrient 即係導致到佢有呢個 deficiency symptom 嘅症狀嘅呢個 nutrients，咁樣佢嘅 mobility 係點樣？因為佢 mobile 同immobile 嘅嗰個症狀最早出現嘅嗰個部位係唔同嘅，咁樣點解你會得出呢個結論？去判斷佢係呢一隻 element 咧，呢個出現症狀嘅部位都好重要嘅。咁個 conclusion 就係話點解你由呢啲 symptom 去得出呢個結論係由呢種 element 導致個 deficiency symptom 喺呢個植物嗰度啦，係啦。呢度有12棵噶啦，係啦，咁樣你哋唔止12棵添，好多，你哋就揀6棵去寫。咁樣然之後咧， 第三條問題啦，個 function layout management strategy of the nursery 咧，咁樣呢度咧就係個曹公潭嘅 nursery 啦。咁我哋之前去參觀啦，咁樣其實每一 part 咁我哋都有 visit 啊，咁樣就去你 label 好晒，佢 label 好晒俾你，咁樣每一 part 係做咩嘢啦？呢度係一個 background information 啦，咁樣佢個 design 啦。咁樣然之後呢度咧就係 Rooftop Republic 其中一個rooftop 嘅一個牆啦，咁樣就係唔同嘅區域就佢都 highlight 咗俾你係種植咗啲咩嘢啦，咁樣然之後佢嘅一個管理啦，咁樣個 design 啦，佢個 purpose 係點樣啦，咁樣就方便大家去答翻第三條問題嘅。有冇咩問題啊？我呢度就係 future report individual group 嘅。我呢度嘅功課全部都係 group 㗎。future report 係 group 嘅 lab report 係 group 嘅。O 唔 OK 啊？呢度有冇咩問題啊？好，其他同學咧，知唔知要點樣做啊？清晰、了解、明白。有冇？大家有冇聽緊？咁然之後個 deadline 咧就係有排啊，4月28號啊，42日啊，暫時未。希望可以大家 keep 到你哋做功課嘅嗰個時候嚇。唔明問下你哋 groupmate 啦，叫你哋 groupmate 要聽明，groupmate 聽明就 OK 啦。有人解釋俾你哋聽，O 唔 OK？好，咁暫時呢兩份功課，咁樣就我會5月頭嘅時候，可能有啲 detail 嘅一啲考試嘅安排，咁樣就會再 update 大家。再 update 大家，我想睇下大家嘅記得啊嚇，呢個又要交喎，呢個 presentation 錄音嘅嗰個嚇，唔好唔記得啊，嗰個 presentation topic。我呢個好似係 upload 咗俾大家，你哋揀嘅嗰個 topic，每一組嘅揀嘅 topic。咁好似我記得係有一組未揀嘅，咁我都 assign 咗俾你啦，assign 咗俾你。咁你哋及時去完成啦，及時去完成啦。咁喺錄音嘅嗰個 file 入邊，我要聽到你哋每個人都有出現啊嚇。暫時係咁咯，我哋休息10分鐘先，然之後我會講埋剩低嘅一個 lecture。好，大家休息10分鐘，1點鐘返嚟，等陣見。 咦，我搞錯咗啊？點會咁嘅？唉，我睇下先，我哋一齊嚟對下，我驚我自己有搞錯。即係而家你哋係 top 第8個 topic 係咪啊？Andrea 係 Andrea 係你哋揀第一個 topic。咦？咁嘅，我睇錯，係喎，第2個 topic。哦，咦？哦，哦，哦，係啊，係啊，係啊，唔好意思啊，唔好意思啊，哎呀，咁我要對翻啦。哦哦哦，係啊，係啊，係啊。咁或者你哋可唔可以介意？你哋每一組有冇人喺度啊？我更正翻啦。我唔記咗呢件事啊。我直接咩？啱咗嘅我就 highlight 佢呢個第8個 topic 呢個啱咗，即係其他嗰啲都唔啱噶咯。第一組有冇人喺度啊？你哋揀嘅係邊一個啊？topic 7 topic 7 topic 7，OK，我走先。咁第一組有冇人喺度啊？第一組冇。咁第2組已經係啱噶啦，嗬。第3組咧，係
Hello，我哋係 topic 6冇記錯係。
係咪呢個 topic 啊？
我再 confirm 一次，等我一陣啊。
好似係頭先係啊，我搞
我哋係嗰個 salinity 嘅嗰個嚟嘅。
salinity。
Miss 啊，我係 Group 2嗰個啊，跟住啱啱一開頭話我哋本身係 topic 7啦，但係 topic 7嗰個題目唔係我哋本身個題目咯，原來3個題
係啊，就有啲混亂啊！你唔好跟邊個 topic 啦，你話俾我知嗰篇文係邊個？
我而家係 long term effects of 嗰個。
係得 long term 呢個
係
呢個，
唔該晒。
你哋係第2組。係啊，唔好睇個 topic 啦，唔好睇一個 topic 名啊，睇嗰個 title 名啊。哎呀，太混亂啦，唔好意思。第一組頭先，我睇下先。Group 1 correlation。好，我哋一組一組嚟啊！唉，我應該對翻嗰個 topic 同嗰個 title。唉，第三組 confirm 到話我知下，第四組啱唔啱啊？而家第四組係咪啱㗎？而家冇出聲，我當啱啊！第五組呢？第五組有冇人喺度啊？第七組，第七組而家啱。第七組啱。第五組有冇人？第六組呢？第六組有冇人？我驚有人同我一樣喎，睇個 topic 又唔睇個題目啊！我驚你哋有啲已經做咗。第八組呢？第八組有冇人啊？
我係第八組 Miss。
係邊一個 topic 啊？
我係當初冇揀個 topic 嘅，但我見你係 assign 咗嗰個 interaction effects of nitrogen form and planting density on plant growth and nutrient uptake in maize seedling 呢個係。
但係之前有冇人已經揀咗呢個㗎？
我唔知，但係我哋已經做嗰啲咯。
好，擺咗喺你度先嚇。
係第四組。
第四組，
我哋個 topic 係 nutrient use efficiency at ecosystem。
即係唔係呢個喎？
係啊，唔係呢個，唔係呢個。
頭先嗰個
係
即係CA 個 topic 應該係第三組嘅。
第三組嘅係咪？
係。
唉，好混亂。係。咁而家得翻兩個未認領，第五組同第六組。我記得第六組係未揀咯，冇人揀咯係嘛？係咪第六組有冇揀過啊？第五組有冇人啊
？Miss，第五組嗰個題啱嘅。
啱嘅係邊一個啊？
嗰個 K 嗰個 dissolution 嗰個。
dissolution 呢個第五組係你哋嘅。OK，
係啊，
咁樣得翻呢個係咪第六組噶？
第六組好似 topic 3嚟嘅。
topic 3係邊個啊？
咩 long term 嗰個咧
？long term 邊個 long term？
咩 long term effect？
撞埋同一個？同第二組同一個？嚇？
睇先。
應該唔會出現撞題目呢個。等我對翻下。嗰個我要開翻嗰個 topic 嘅嗰個 presentation。long term 呢個應該係 topic 3。係喎，呢個應該係 topic 3。topic 3係邊個揀咗 topic 3？topic 3係 topic 3。
第六組咯。
係喎，你哋係喎。Livian， 你哋有冇搞清楚啊？係佢哋揀嘅喎，呢個 long term 呢個。
應該係我哋一開頭睇錯咗另外一個嘢，所以係咯，你俾咗佢冇辦法。
你哋係揀咗 topic， 你哋係揀咗 topic 7係咪啊？topic 7咁就應該係 topic 7。係啊，呢個先係你哋㗎。咁就啱啦，係咪啊？大家 confirm 一次啊！自己做嘅係呢一份 paper 啊。 O 唔 OK 啊？我呢個等陣再 update 一次啊。我等陣將呢個 upload 上去冇度更新咗嘅呢個。係啊，你哋唔講就好容易會搞錯咗。好，我等陣 upload 上去。其他仲有冇咩問題啊？好。冇嘅話，我哋就繼續我哋嘅 lecture。我發現我可能唔夠時間講。我哋講到第六個。講快少少啦，哎呀。Okay. Determination of soil and plant nutrients. And in this lecture, in this chapter, we talk about how to measure different nutrients content. For example, how to measure the total form, available form, or how to measure the nitrate and nitrite, and the mechanisms that we use in our lab for the determinations. So total nitrogen is an essential nutrient for plants and animals, and I have a different source for the total nitrogen. So it can come from the wastewater treatment plants or runoff from fertilized lawns and croplands, or the falling septic systems, or the runoff from the animal manure and storage area, as well as the industrial discharge that contained corrosion inhibitor. And the soil testing for different nutrients. The total nitrogen represent for the total nitrogen and inorganic nitrogens. Why could we run the total nitrogen on soil if the precision is not that high? And why the total nitrogen is very important that we need to know, even though the precision is so low. For the long-term experiment, we need to know the storage for the total nitrogen and the nitrogen sink. And also, we need to know the carbon nitrogen, the CN ratio is very important for the plant's growth and the soil structure. And the nitrate is seldom present in the detectable amounts, and so that's why for the available form, the nitrate and nitrite, we need to measure it immediately. And for the total form, we can store for a long time, and for the total form, such as through the acid digestion, we need to convert the available nitrate, nitrite, and convert it as the ammonium forms that we can measure the total ammonium, and these ammonium forms is represent for the total nitrogen in the soil or in the plants. And the soil testing for the different nutrients here shows two major test methods for the total nitrogens in the soil. It reflects the basic mechanism. And if we use the CFA, it also used the similar determination, similar mechanisms. And here shows the total nitrogen, and it also need a high temperature and need to digest, and also consists the heating of sample need to reach the 316 to 410 degrees Celsius, and also with the concentrated sulfuric acid. And then the decomposed organic sample by oxidation to liberate the reduced nitrogen as the ammonium sulfate, and through the decompositions, then all the available nitrogens or different forms of nitrogen convert as the ammonium form. That for the further determination, we can use the method to we can use the cadmium column to measure the ammonium concentration, that we can know the concentration of the total nitrogen. And dividers, we can use it as a reducing agent, as a source of donor electron to reduce nitrate and nitrite to ammonium. So in the compost, we can add different elements to accelerate the reactions. Another dry combustion methods is through the combustion the sample under conditions where the resulting combustion products can be quantitative analysis determine the empirical formulas or the partial empirical formulas and calculate the original. And here also we release the nitrogen, ammonium, the nitrogen gas, and use the oxidation reaction. So the combustion, here shows a reaction through absorption for the nitrogens, that we can measure how many total nitrogen in the sample. And here also need a high temperature for the combustion. And as oxygens also being removed in the reduction reactor. Because in this reaction, you need a higher temperatures, you need a higher the 615 degrees Celsius, and this high temperature to turn all the nitrogen compound into the gas form. And here shows the mechanism. It have the two reactor, combustion reactor and the reduction reactor. The combustion reactor is the sample weight in the tin container. The container, the material also need to can tolerance for high temperature. And the combustion reactor enriched with the pure oxygens higher than the 1000 degrees Celsius in the combustion tubes. And when it reached 1700 degrees Celsius during the fresh combustions, and that it can complete oxidation. So you can see that it need to reach a very high temperature that they can finish the complete oxidation for your sample. And the fresh combustion converts all organic and inorganic substance into elemental gases, and that is stable the compound combusted. And the combustion products pass through the oxidation catalyst of the chromium oxide, and later they will pass through the reduction reactor. The reduction reactor, and the sample heated with the copper oxide and had higher temperatures in a steam of carbon dioxide, and the gases lost at pass through a hot copper to reduce the nitrogen into the gas form. So the next over the copper oxide to convert the carbon convert into the carbon dioxide released. And also in this method we need to pay attention that some materials, and if the nitrogen exists as a form for the heterocyclic compound, it's difficult to burn. So if you and it may cause the underestimate for the nitrogen concentration. And so inorganic nitrogen determinations that we always say is the available forms, and also the ammonium form, we can use the steam distillation with the magnesium oxides, and they will show the color different. It will show the indophenol blue. So if you use different indicator reagents, they will have a different color change for the titrations, that you can know the end point for your determinations. And nitrate and nitrite, we can use different methods, such as the phenoldisulfonate acid, or chromotrophic acids, or use the selective ion electrodes, or the cadmium reductants, as well as the steam distillations. And the inorganic testing, nitrogen testing, does not work in some soil. So for the different target soil, that we can use the different methods for the inorganic nitrogen testing, because for example, in some situations such as the high organic matter, high mineralization potential, and consideration of ammonia, or some amide groups from the nitrogen cycle, or the rapid change in for example, the biological transformation, and these will affect the inorganic nitrogen testing result, may underestimate or overestimate for the actual results. So for the determination method, extracting solution, we have a clear understanding and consideration for it. And phosphorus soil index procedures, and here shows the commonly used method is created by the Braid and the Cruz, and they will use the hydrochloric acid and the ammonium fluoride, and for the extraction solution, the fluoride ion in together with the hydrochloric acid as extractants. So remove the easily acid soluble forms of phosphorus, and also the ammonium fluoride can dissolve the aluminum and the iron phosphorus, the fixation compound of the phosphorus, and make it become dissolved in the solution. So use the strong acid can extract all the phosphorus in the soil, that to measure the total the total concentration of the phosphorus. And the extractable phosphorus, and is the pH of the extracting solution is very important, and it determines which forms of phosphorus can be extracted in the soil, and it depends on the strong the level, the level of the acid you used. So different level of acid depends which type of phosphorus, which level of phosphorus will be extracted from the soil. So what will happen if the Braid and the Cruz method was used on the calcareous soil, and the lime and the calcium carbonate in the calcareous soil would neutralize the acidity in the extracting solution, therefore will decrease the ability to extract the fixed phosphorus, will affect the extractants for the phosphorus in the soil sample. And the total phosphorus was not correlated with the plant availability. Even though you measure the total phosphorus is a high level, it doesn't mean that they are available or they can be used by the plants. And various strengths of the extracting solution were evaluated for the specific soil and selected soil pH that mirrored what the plant could find in soil solution, and determined the phosphorus concentration from the dissolution of precipitated fluid. An attempt to correlate extractable phosphorus with total phosphorus will result in meaningless information. So, the total phosphorus will in a sense dissolve phosphorus from that will not be available at the soil's specific pH. And here talk about the potassium. And also the potassium can be divided into two forms, available forms and the total forms. And different extraction for the different forms for the potassium. The soil solution potassium can be extracted by the distilled water, calcium chloride, or the displacing cation extractant can use the ammonium acetate, ammonium chloride, the barium chloride, the ammonium bicarbonate, and DTPA. And also the precipitating extractants can use the DBK, is the sodium tetraphenolate. And it may sometimes be necessary to convert one soil potassium test value to its equivalent value for another extractant that is well calibrated and accepted for the fertilizer recommendation in the areas. So the extracted potassium can be converted as a different part. And the potassium uptake, the extraction method. The end over end shaking through the lectrin will cause the extraction for the potassium. Here shows the different method. The solutions, the calcium chloride can extract this part. If you use the DPK for extraction, you can extract this part of potassium's forms, and if you use the ammonium can used to extract the extractable potassium and solution potassium. And the nutrient interaction here shows that the high potassium by mass action displaced aluminum ion compressed with the phosphorus, inducing a net phosphorus deficiency and increase in the concentrations of phosphorus in the roots above the threshold values, and could cause the zinc deficiencies. Dispersion of zinc concentration in the plant tissue of phosphorus, and will interaction occurs in the plants of not in the soil. And here shows the spectroscopy methods for the different determination. And for the first one, it shows the percentage, the interaction radiation energy, and the matter is showed for the neutrons, atom, or the molecules. And spectrometry, it shows it used for the measure the radiation intensity with the photoelectric transducer and the electronic device. So most of the values, the determination of auto one used in infrared this range for the determination, and the microwave and NM are more detailed for different elements determination method. And here shows the mechanism, how does the CFA and AAS and these auto runs spectroscopy absorption, how does these machines mechanism here reflect that they used, they need to calculate for the absorbance of the analyst and the incidence radiation need to pass to the sample, and then through the picked area, the picked shape can reflect the determined concentration in your sample, and also reflect the intensity absorptions. And here shows the UV visible molecular absorption spectroscopy, and also they need to use this equation, and this part just for you as a reference, and it illustrates the mechanism for your sample determination by machines that we used in our lab, and some of them use the one sample, some of them is double beams, can measure the two sample, and here shows the single beam, the double beam, the sample cell that you need to put the control first, and another one that have a specific channel can run the sample cell and the reference cell at the same time. And the wavelength selector, the different elements, the different molecular elements have their preferred highly absorbed wavelength. So you need to, according to their recommended wavelength, to select the determination wavelengths for your sample determinations. And the filter. The filter have a preferred light for the color, the absorption. Different filter have help to increase the absorbance for the wavelength for the sample. And here shows the holders for the auto run. Also, you need to put the sample into the holder in the cells, or other HPLC for further moleculars or the compound pollutants determination. They also use the holder for the sample, that to ensure the needle or the wavelength or intensity of the light can pass through the holders to ensure the absorption for your sample. Detector is the radiation transducer, and have a high sensitivity, and this one is the signal and noise ratio, and the constant power response over a considerable range, and that you different detector have a different spectral regions, and for specific for different wavelengths. And here shows the lamp, the photo cells and photo tubes, and for the photo tubes can release the different energies for the electrical signal. And AAS here shows the process occurring during the automizations, that you can find the atoms. They have their preferred atoms, so not all the heavy metal or all the nutrients ion can be measured by the AAS. That's why And for some atoms, they cannot reach a high determination rate because we have uncertainty effects or the Doppler bordering and the pressure bordering caused by some elements. So for the sample introduction methods, so AS used the frame having the high temperature and a more advanced instrument that we use the ICP. ICP has much more higher temperature, and then in these ICP that we can measure all the metals at the same time is a much more advanced equipment and also more expensive. For the frame atomization, that here illustrate the mechanism for the AAS. How does the concentrated tube to measure the sample, and how does the frame atomizer can burn your sample. And here shows the instrumentation of AS, and some of them is single beam and some of them are double beams. And in our AS, at the eye is the single beam frame instruments, and so every time only can measure one sample, and you need to run the control first or adjust it. And the lamp is the hollow cathode lamp that we use for the AAS. The chemical interaction, so some chemicals are not should not be measured in AAS because they have some interaction during the process. And here shows the background corrections in the AAS, and try to make your sample shape like this. The response area should be like this, and if you show it like this, it's not a success determination. You need to measure it again to ensure it have a quantitative analysis for your samples. And here shows the ICP. The ICP have a more sharp and a more narrow pits for each element, so each one represents one element, so they can measure all the compounds at the same times. And here shows the burning mechanism. The burning method for the ICP is show a difference with the AAS, that they can reach a better. So here shows advantage of ICP torch over the frame AAS. And here shows that the ICP can reach the quantitative analysis and the quantitative analysis for your sample because it can set the integral standards inside. And except for the lamp determination, we can use some on-site determination. For example, the near-infrared reflecting spectroscopy. It is an analyzer which is connected to a computer, and that can focus in the red rays on the prepared sample or pulverized plant materials, and they can measure ring the vibration caused by the stretching and the blending of hydrogen bond with carbon, oxygen, and nitrogen. And each of the major carbon components of forage or other feeds have light absorption characteristics. And here shows like this, and also have the chlorophyll meter that you can use the on-site, use the light absorbance at 413 to 715 nanometers. Is no new tissue collections. It's just through the just use the leaf chlorophyll is light attenuation through the light absorption. And also have the on-site meters. We can use the meter to measure the MPK on site. However, they don't have the accurate reading for this parameter. But however, we can have a roughly determination on site. No need to collect the sample. If you have time, you can search the YouTube that they use the on-site determinations and through the on-the-go chemical analysis that they measure the goal performance, the basic nutrients level on site that like this, and they can measure the different elements with the productions on site and the spectral radiance and the rates of flow of light energy reflected from the surface and the rates of flow of light energy reflected from the surface from the plant canopies that can excellent predictors of a plant's nutrients uptake. And here compare the soil testing and the sensors and their benefits and their disadvantage and advantage. And here you can see that above ground, most of them can use for the sensor for the determination. And however, the below ground is suggested to conduct for the soil test that you can get a more complete and a more detailed or more accurate data for the nutrients and that corresponding to your nutrients management and productions. And here shows our evolution of the soil test and the spectral test. And here show the reference example of smart agriculture that we should think how to conduct the smart agriculture in Hong Kong. Should we use the soil sensor to replace the determinations in the small scale agricultural farms like this? So I think I don't have enough time for the next chapter. 好，咁我唔係好夠時間講晒佢啦。咁我第7個 chapter， 我第7個 part 呢個唔係好多內容嘅啫。咁我大概可能得10零張嘅 PowerPoint。咁我會錄音，我第7個 chapter 呢度我會錄音，然之後再 upload 上嚟。好，咁我哋今日就上到呢度，我哋等陣都要上 Caroline 嘅堂，咁樣就你哋有冇咩問題啊？如果冇咩問題嘅話，咁我哋呢一堂咧就 lecture 嘅內容就上到呢度啦。咁樣大家要記得要做功課啦、交功課啦，咁樣就如果有咩問題嘅話，就可以 WhatsApp 我啦，或者 email 我都 OK 嘅。好冇？咁我第7個 chapter 嗰10幾版嗰個錄音再擺上去。Moodle， 咁樣然之後我執咗嘅嗰個 presentation 個 list 咁樣咧，我等陣會再 update， 大概係咁樣。OK， 好，快啲去食飯啦，拜拜，
拜拜，
拜
拜拜，
拜。
拜拜。
拜拜。
拜拜，
拜拜。
嗯。